Yes, good evening. Right. Let us start the topic now. Right. We have discussed single phase power measurement, right? In that, we have seen MC short and LC short method. What I told you, this is for low current applications, or we can say high resistance applications. Here, low resistance application, or we can say high current applications, right? But in order to have same error in both the cases, what is the formula? REL is equal to root of RCC into RPC, right? And after that, in this self-inductance error, what you have taken? Percentage error equal to plus or minus tan phi tan beta into 100. I have used this formula. We have taken so many questions. You need to use this formula only because all the theories or all the concepts are built up based on this derived formula only. Right. In order to get this one, what we have taken? One is ideal procedure we have taken, and one is practical procedure we have taken. Right. Now, in the ideal case, what we get? True value. Yes or no? True value. What is it? What we have got? IC V phase into cos phi. Practically, what we get? Measured value. That's why, sir, in order to say true value, in order to obtain true value, ideally, what I have taken here? LP is equal to 0. Why? We are going to find out the error due to LP only. I made LP 0. Why? Error will be 0. If error is 0, automatically, the correspondingly true value are going to get. That's why I made LP 0. Here, LP is not equal to 0. LP is not equal to 0. This is measured value. What you have got here? IC V phase cos beta cos phi minus beta. Okay, right. And a few people are asking that, sir, why you have taken all these things? Why can't we write directly? Yes, very simple. Yeah, very simple. Concentrate here. Right. Sir, here in the circuit, current coil is there like this, load is there, and potential coil is like this. Okay, right, sir. So why we have taken this entire ideal condition? Why can't we write directly? So true power is, sir, this is VL, right? VL. The true current is IL into cos. We can write it. We can write it. But what is VL in our discussion? V phase. Okay. IL is nothing but IC into cos phi. We can take directly, but how do we get true value when the data is not given directly? For that point of view, I give the complete procedure. Take the ideal condition and proceed for determining the true value of power. Otherwise, without this entire thing, directly you can write, sir, VLIL cos phi. VL is equal to V phase because current coil drop is being neglected. And IL is equal to IC into cos phi. You can take directly, but I give the procedure how to determine the true value also mathematically that I gave you. Clear? Right? Okay. People are asking one more thing. I told you to, what is it? 1 by correction factor minus 1 into 100. Right? If you're deriving what I told you, tan phi, tan beta into 100 means by some approximations, whatever the small value is there, neglected compared to other terminology and bring it. So you'll be getting this value. That's why always in the derivation, you have to concentrate one thing. In your derivation, if any small parameter is there, combined with high parameter, suppose large parameter with small parameter, you can neglect the small parameter. By that entire thing, you take this, but I'm repeatedly saying, based on this only, all practical theories are built up. Based on this only, all practical theories are built up. Based on this formula only, in the examination, options will be given. In the examination, options will be given. Clear? So this is the total point regarding yesterday's topic. Right. In the derivation, whatever you can neglect it. Otherwise, leave the mathematics and take the formula directly. In this mathematics, kindly don't have any doubts. That is simple mathematics only. Simple mathematics only. Right? Whatever the terminology you are getting, just simply neglect it. That's it. Right? Okay. Now, other than that, what we have taken here, we have calculated the corresponding errors also, and we proved also. What is that? Tan phi. Phi must be low during the operation. Beta must be low during the designing. If the beta is low, means potential coil is made up of low inductance, automatically the error will be low only. We have taken conclusion. Okay, right. After that, three-phase power measurement, I gave the introduction. In the three-phase, how many loads, how many types are there? In the three-phase, how many types are there? Right, two types are there. What are those? Balanced and unbalanced. Introduction also gave you what do you mean by balanced and what do you mean by unbalanced, etc. Okay, now we are going to take each and every circuit. The first one, in order to understand that entire thing, I need to give small topic, phase sequence. Sir, as the three phases are there, sir, here, as the three phases are there, which phase must be taken first? Because I told you, no, each and every phase must be displaced by 120 degrees with each other. I told you. In the same way, which must be taken first, which must be taken later, means generally we follow R, Y, B sequence. Generally, this is the terminology. Sir, why only R, Y, B? There is no logic. Red, yellow, blue, that logic you are following. I am taking R, Y, B sequence. Sir, how do we define R, Y, B sequence? How do we define R, Y, B sequence? Be clear. So how many phases are there? Three phases are there. That's why I'm taking the phasor diagram. Sir, this is VR. This is VR, or simply I'm writing R. Okay, this is R. First R I'm taking. Y, B, R, Y, B. So therefore, among these two, which is correct, you tell me. I'll be giving two diagrams. Which is correct, you tell me. Whatever is wrong, we can erase it. This is R. This is Y. This is Y. This is B. And this is B. Now, which is the corresponding phase sequence? RYB phase sequence. In which figure it is there? Figure 1, figure 2. In which figure RYB sequence is there? In which figure something else is there? A few people give that first, few people give that second. See, sir, people are saying both are correct. Few people are saying both are correct. Few people are saying second is correct, and few people are saying first is correct. Be clear, guys. If nothing is mentioned, if nothing is mentioned, in this I have not mentioned which sequence, positive or negative. If nothing is mentioned, we talk about positive sequence only. We should talk about positive sequence only. Always be clear. The positive sequence means anti-clockwise sequence. This is anti-clockwise sequence. This is called as positive sequence, right? In this, what is the available sequence? Positive sequence in this, which is there here, R Y B sequence is there. R Y B sequence. What is that? Concentrate. Start from here. R Y and B. Now that's why what is the sequence in this RYB sequence? But instrumentation people, you may be having doubt, like concentrate. Anti-clockwise means we should not rotate. Sir, R, I'm going to be. No, we should not rotate. Which should rotate? Vector should rotate. That's why stand at any one place. Hold the junction and rotate the vector system, phasor system in anti-clockwise. Phasor system in anti-clockwise. So therefore, automatically here, first it is which is coming to you? R. Then which is coming? Y. Later B. That's why RYB is a phase sequence. That's why kindly instrumentation, especially I'm worrying about more about instrumentation, because electrical people already know this. This is just like a revision to them. But other people, kindly concentrate. What is it? You need to stand at one place. Vector system should rotate. You should not rotate. Major doubt is, sir, R, B, Y, no. We should not rotate. We should stand at any one place. So stand it here. R is first, Y later, B later. Okay. What people are asking, sir, why only standing over there? Why not some other place as you wish? Sir, I want to stand at this point. Yes, no problem. Hold this junction. Rotate. What is that? Y first. B, R. If you observe this keenly, R, Y, B, R, Y, B, R, R, B, R, Y. Everything is same sequence only. R, Y, B, R, Y, B, R, Y, B means automatically R, Y, B will be there. Y, B, R as well as B, R, Y also will be in the picture. That's why anything is same. So that's why wherever you're standing, where you're standing is not the matter. Where you're standing is not the matter. How you're rotating is the matter. That is positive sequence only. We talk about anti-clockwise only. Suppose in this only, if I rotate in clockwise, if if you rotate, that is called as negative sequence. Concentrate. We should not rotate, and we are not rotating here. Only vector system should rotate. Right? So therefore, here, sir, clockwise means what you have to do? You should rotate the vectors, or you should rotate the vectors. Sir, R first. Then which is coming? B. Then which is coming here? Y is coming. So therefore, what is the sequence now? R, B, Y is a sequence. I have repeated almost 3-4 times. Concentrate. I told the point also. We should not rotate. We should rotate here. System should rotate. That's why hold this. First R, then Y, then B. So R, Y, B anti-clock. But still people are typing that, sir, anti-clock, R, B, Y is coming out means you're not listening. Concentrate. Here, first R, then Y means vector should rotate. That's why I told you, stand at this place, rotate here. Towards you, which is coming first? R, later Y, later B. Clear? This is the actual point here. So that's why we should not rotate. We should not rotate ourselves. We should rotate which one here? Vector system only. So this is a simple introduction regarding total three-phase system. Introduction only. Now I'll be taking one by one. But be clear, I am discussing about three-phase power measurement only. Be clear, three-phase power measurement only. Because the topic itself is power measurement. Now, sir, what I told you in the introduction, what I told you here, in the measurement of power, How many methods are there? Three-phase power measurement. Introduction of power measurement day before yesterday I gave you. What is that? 1 watt meter method, 3 watt meter method, and 2 watt meter method. Three methods are there. Three methods are there. Right? Okay. Now, sir, I'm taking 1 watt meter method. So I'm taking 1 watt meter method. Sir, if I want to use 1 watt meter method, right? For which measurement? Three-phase power measurement. Which measurement here? Three-phase power measurement. So therefore, concentrate here. Power three-phase, we need to get power three-phase. Sir, how many watt meters are there? Only one. But how much power we want to get? Three-phase power. Sir, with 1 watt meter, how do you get three-phase power? Means here, 3 into watt meter reading. If I say left hand side and right hand side, both will be same or different. Left and right hand side, both will be same or different. Same, by 3 into watt meter reading is equal to power three phase. But in order to say both are same, now tell me 3 into. So watt meter should be connected in a circuit such that it should measure single phase power or any combined phase power or any two phase power or etc. Means 3 into which power here? Single phase power only, called as three phase power. Means concentrate, watt meter should be connected in the circuit such that should measure single phase power only, but not the three phase power, but not the two phase power, but not anything else, only single phase power. So therefore 1 watt meter reads one phase power multiplied by 3 to get the three phase power. That is what the actual meaning of 1 watt meter. And sir, 3 into what is single phase power? V phase, I phase into cos phi. 3 V phase, I phase, cos phi. Clear? Okay. Now, with this entire introduction, now we need to analyze. Sir, 1 watt meter method is suitable for balanced load system or unbalanced load system. 1 watt meter method is suitable for balanced load system or unbalanced load system. Means here we are going to measure only one phase power. We are going to measure only one phase power. So therefore, one phase power you are measuring into 3. One phase power into 3. If you are doing like that, all the three phase powers, all the three single phase powers must be equal or need not to be equal, must be equal. That's why this 1 watt meter method is suitable for which one? Only balanced system. Only balanced system. Right? Okay. Here small doubt may be there. Sir, why it is not for unbalanced system? Let me take. Sir, here three phases are there. Like this, three phases are there. Right? Suppose if it is unbalanced system, Z1, Z2, Z3. Okay. What I'm doing now, 1 watt meter is connected here. I measured power consumed by one phase. Suppose I'm saying that this is 100 watts. So can I say total power three phase is equal to 3 into 100, that is 300 watts. Can we say? No. Why? Z1, Z2, Z3 means unbalanced, means different impedances, different, what is that? Power consumption compulsory. If different power consumption is there, can multiply by 3? Definitely. No, that is the reason why. What is it here? This entire system is suitable only for which one? Balanced system only, but not the unbalanced system. First point. First objective point is this. Balanced system only we get. Okay, right. Next. Sir, in the balanced system, how many connections are there? Star connection. As well as second one, delta connection. Star connection and delta connection. Sir, what is star connection? What is delta connection? I'm going to take the diagram, and everyone know the diagram figure, you know, but analysis I'll be taking clearly. Concentrate. Sir, which system? Balanced one. I'm taking star connected structure. This is one load. This is one load. This is one load. Okay, sir, what is that here? Z, Z, and Z. Sir, I'll be drawing neutral wire. I will be drawing neutral wire with dotted line. Because neutral wire may be there, may not be there. Practically in the load point of view, neutral may be there, may not be there in the load connection point of view. But that's why I told you yesterday's introduction. What is that? Three phase, three wire. Suppose if neutral wire is not there, how many phases? 1, 2, 3. How many wires? 1, 2, 3. So three phase, three wire we can say. Listen, suppose if neutral wire is there, that is called as three phase, four wire. So which is best and all? So many doubts will be there. Concentrate, everything will be cleared one by one. Sir, I'm taking this as R, Y, B, and N. Okay, sir, what meter should be connected in the circuit such that single phase power is to be measured? What meter is to be connected such that single phase power is to be measured? So that's why, be clear guys, be clear. Here I'm connecting one wattmeter. This is current coil. See, you can take two parts or one parts in the symbolic, no problem. And potential coil like this. Sir, I'm connecting to neutral. I'm connecting to neutral. Sir, now this entire wattmeter measures single phase power or any two phases power or three phase power directly. In this figure, this wattmeter connection, whatever I have showed, is it measuring single phase power or any combination of phase powers, or three phase power means single phase power only. Why? Concentrate here. Sir, just erase this and check it. Sir, is it just like yesterday's circuit or not? Yes, yesterday's circuit was single phase. Same thing, single phase is there. So that's why the wattmeter should be connected in the circuit such that single phase power only to be measured. Single phase power only to be measured. Okay, but here problem is there. So neutral wire is there. We can connect the wattmeter like this. Suppose in the question, in the corresponding given circuit, neutral wire is not there. Where you have to connect this potential coil? If the neutral wire is not there, where you have to connect the potential coil? Means, concentrate, either here or here you have to connect. So therefore, what is the point now? What is it? The potential coil of the wattmeter should be connected to neutral wire, but neutral wire is not there. If neutral wire is not there, either we should connect it to B wire or Y wire. Okay, Y wire for example. Is it measuring single phase power so that we can use the formula? No, it is not measuring the single phase power. Sir, why? Check it. Sir, current coil is measuring two phases current, and potential coil is also across one and two phases. So therefore, it is not the single phase power. It is combined phase power, or it is more than the single phase. Sir, if it is more than the single phase, can we use this formula? No. Therefore, if you're not using this formula, our basic approach will be violated. Yes or no? So that is the reason why the neutral wire must be available, or need not to be available means available. That's why conclusion is, I'll repeat, don't worry, concentrate. The 1 wattmeter method is suitable in balanced system. That is okay. But in that balanced system, star connection is there. No. For which type of star this is valid? Means, what is it here? Star three phase, three wire system, or three phase, four wire system means three phase, four wire. If fourth wire is not there, where do you connect the potential coil? Where do you take the return path that is disturbing the main equation? That is the reason why, what is it here? The 1 wattmeter method is suitable. 1 wattmeter method is suitable only for three phase, four wire system. If fourth wire is not there, it is not suitable. Fourth wire is not there, it is not suitable. Right? Means the star connection, three phase, three wire, or three phase, fourth wire, 1 wattmeter method problem is, that's why 1 wattmeter method is not a universal method. That is condition based method. What is it? neutral wire is compulsory required. Means three phase, fourth wire is required. If fourth wire is not there, automatically the thing will not be satisfied. We cannot measure the power at all. One thing. Coming to delta connection. See, all these things will be new to you. Kindly let me explain clearly one by one. Definitely you will understand if you concentratedly listen. Right? Concentrate here. And this is load delta connection. Right? Delta connection. This is R, this is Y, this is B, and Z, Z, Z. Okay, right, sir. Here, delta automatically, how many wires should be there here? Only 3 wires should be there. Of course, definitely. Delta itself is a triangular shape, closed path looking like. So automatically 3. That's why delta 3 phase, fourth wire will not be there. 3 phase, 3 wire only will be there. 3 phase and 3 wire. Okay, this is R. Now, wattmeter should be connected in the circuit such that it should measure single phase power. How do you connect wattmeter? Is it possible or not? If it is not possible, what we have to do? Everything we are taking. Right. Electrical people, those who are done with the network theory, suppose whoever have completed the network theory, they know this topic. But except those few people, everyone, network theory is not done in the AS Academy. Other people, IN people, this is completely new to you. No need to worry. Right? Sir, here, what is that? Sir, our wattmeter. Where we have to connect the wattmeter? Simply in any one phase, single phase. So therefore, 1 wattmeter current coil and 1 wattmeter potential coil. Where should we connect? Either Y or B. Okay. Sir, this wattmeter measures which power? Single phase power or any mixed phases combination, etc. or 3 phase directly. Means, see the diagram properly. Here, sir, current coil is carrying the current of at this point these two currents, and this also means the current coil is carrying the current of all the 3 phases but not single phase. Okay, and voltage is anyway no problem. Voltage, yes, voltage across one phase, but voltage across one phase is there not sufficient. The entire power must be single phase, but in this more than the single phase. Why? The current coil is carrying the current of all the 3 phases. Current coil is carrying the current of all the 3 phases. Therefore, in this connection, we are not able to measure the single phase power. Thereby, we cannot multiply by 3 like this. Thereby, we cannot say 3 phase power. We cannot say 3 phase power. Clear? This is what the actual is. Therefore, my question is, sir, if you take 1 wattmeter method, star 3 phase 3 wire, we cannot use it. Delta connection, we cannot use it. Only where you can use star 3 phase 4 wire is given to you, then only you can use. Suppose people are asking this doubt, sir, automatically 3 phase 3 wire only no, 3 phase 4 wire only no, why are taking like this, etc. You guys see, kindly concentrate. Here, if you purchase the equipment in your laboratory, if you take equipment in the laboratory, suppose in the practical laboratory measurement, sir, here, if the load is to be taken, what you say, no, I want a resistor load of so and so capacity, 3 phase resistor load. If you say like that, they will give this type of load. Some load will be there, right? On this nameplate details, it is given as star 3 phase. But if you see outside, only R, Y, B. This is star only. Load, one box will be there. Star 3 phase 3 wire will be given by whom? Manufacturer. Now tell me, where is the neutral wire in the practical case? Is it there? No. That's why our duty is to connect wattmeter here to here or here to here. So therefore, automatically the corresponding wattmeter measures more than the single phase. Why? Phase to phase current is with respect to two phases, voltage also with respect to two phases. Therefore, automatically we don't get the single phase power. But what we should get here? Single phase power we should get. After that, we need to multiply with 3 to get the three phase power. But in this case, it is not happening. Okay. Suppose people may be saying that, sir, in my laboratory, I have seen like this. That's what I'm telling. Sir, I have seen this type of load also. There are Y, B, N. Sir, I used in my laboratory like this. Okay, happy. If this is the load with you, if this is the circuit available with you, yes, 1 wattmeter is possible. How, sir? R2. Which one here? Neutral. R2, neutral. Over. What is that? Phase to neutral, single phase to neutral. So automatically single phase power. So that's why conclusion what I gave you, we have 3-wire system, 4-wire system also in the star. Suppose if you have 3-wire system, 1 wattmeter method cannot be used. Suppose if it is a 4-wire system, 1 wattmeter method can be used. That's what the conclusion. Second thing, delta not completed. Delta. So delta anyway 3 wires only. Suppose if I connect the wattmeter like this, does it measure single phase power? No, it measures combined phase. Why? Sir, current coil current. Here, current coil current, right? These two phases and this and return path. So therefore, current coil current carries the, otherwise CC carries the current of all the 3 phases. Sir, once it is having all the 3 phases, do you get single phase power? No way. That's why with this wattmeter, single phase power measurement is not possible. So therefore, what we can say, universally 1 wattmeter method is, what we can say, 1 wattmeter method is not universally acceptable. It is acceptable condition based only. In the star connection, 4th wire is required. In the star connection, 4th wire is required. Otherwise, 4th wire means neutral wire only required. Otherwise, we cannot use it. Okay. Second thing, in this, what is the problem? Even though it is a 3-wire, but delta, etc. No. Therefore, neutral wire question itself is not there. Neutral wire, there should not be any question at neutral wire because it is delta. That's why the corresponding single phase power measurement, if you connect like this, not possible. Okay. Sir, how is it possible means? See, what I'm doing now, I'm erasing this. Simply I'm erasing that. After erasing that, concentrate. Sir, current coil I have connected here. Potential coil I have connected here. Now, everyone, just see the figure and analyze it. Sir, this measures, this wattmeter measures single phase power or any 2-3 phases power or directly 3 phase power, means single phase. Now, how? Check it. Sir, current coil only 1 phase current. Current coil only 1 phase current because it is series with this one. After that, sir, potential coil is also here to here across 1 phase. Automatically this wattmeter measures single phase. Sir, this wattmeter measures single phase means into 3 is equal to 3 phase power, is equal to 3 phase power. So therefore, what is the condition again? In the delta connection, in order to measure the 3 phase power by the 1 wattmeter method, what you have to do? Simply concentrate here. I did like this. Okay, erase this. I told you like this. Right? I told you erase like this. Yes or no? But what do you mean by that erasing? What do you mean that erasing means? I opened the load. I opened the load. Is it possible to open the load practically by the operator in the laboratory point of view? No. What does it mean? You know, people are thinking that, sir, why can't we do like this? I can do, you can do on the paper. But practically, we cannot do like this. What does it mean? It means we are opening the load. Means, suppose if the box is like this. Which one now? 3 phase delta load, they will say. Okay. R, Y, B. Anyway, 3 ways only. R, Y, B. Okay, sir. Load must be open means in the figure it looks like, okay, erase it. Not like that. Not like that. What is it here? you need to open the load. Means you need to open this entire box. Whatever the wheels and structure is there, no, you need to open the entire load box. But as the operator, is it possible? No. Second thing, don't think the negative way with the statement. People are thinking like, sir, why it is not possible? I will open. The meaning of this is you should not open. I'm not saying that you cannot open. What is the meaning? You cannot open. Think, simply take the screwdriver and tester. You can open it. But I'm not saying that you should not open. As the operator, you should not open because if you're opening that, some seal will be there. Some seal will be there. That seal may be broken. If the seal is broken, warranty will be lost. If the warranty is lost, no free service and all. This is actual problem. Second thing, very, very important here. Even though you open the load, time waste. Concentrate here, very, very important. Even though you open the load, time waste. Why? Means people are thinking that if I open the load, means after opening the load, I will observe this type of delta. No. This type of shape will not be there, such that, sir, okay, erase this one. No, yeah, no. Physically, for writing purpose, we write like this delta. But practically, connection, manufacturer to manufacturer, winding structure is different. That's why even we open that load, time waste. More than that, nothing is there because we cannot understand where is R, where is Y, where is B as the operator. Okay, next. Suppose even if you open that, if you do something else in the modification, because of the load may be disturbed completely. That is the reason why load cannot be opened by the operator. Load is only opened by manufacturer. Right now, come back. So what is the logic now? Here, I'm repeating the entire topic because the next topic, 3 watt meter method, same story will be there. What is it? Let us see. Sir, balanced system only. 1 watt meter method is balanced only. Sir, in the star connection, 1 watt meter method is possible when fourth wire is there. Okay, when fourth wire is not there, it is not possible. So condition is there. Second, delta connection. Sir, 3-phase power measurement is possible with a delta connection with 1 watt meter method when we open the load. If you are able to open the load, we can connect like this. Okay, circuit wise, okay. For me, I will simply erase this. But practically, is it possible? Practically, is it possible? No, practically, it is not at all possible. Why? We are the operators, not the manufacturers. Now tell me, universally, sir, 1 watt meter method is universally acceptable or condition based acceptable? Means condition based. Why? Fourth wire is compulsory required here. If not, we cannot use, and load must be opened practically, but it is not possible already. So therefore, 1 watt meter method is not universal method. It is a condition based method. Clear? Clear, guys? Right. Kindly concentrate. I'm not giving the total 3-phase basics now. 3-phase basics, what I require, I gave you, right? Other than that, 3-phase circuits, complete basics, what is neutral, what is R, etc. You'll study in the network theory for which one? Electrical people. But IN people, whatever I'm taking, that is more than enough for my measurement of power point of view. So no need to worry. That in the missions, I'll be taking again for you IN people. For you, I'll be taking 3-phase induction motor later. But be clear. Kindly, I'm requesting everyone, don't ask about the delta circuit basic, why it is like this, etc. That you study in the normal thing. Okay, that's why our topic is 3-phase power measurement. In order to measure the 3-phase power measurement, whatever the basics I require, I'm taking those only, because 3-phase power measurement itself is 2-3 hours topic approximately. 3-phase basics explanation and all 2 more 3 hours, that is network theory model action. So no need to worry, right? But every basic I require related to measurement of power, no need to worry. Clear? After I take unbalanced one, you'll understand what is that. Now, second one. So 3-watt meter method I'm taking. 3-watt meter method. 3-watt meter method. Right, concentrate. Sir, what do you mean by 3 wattmeter method? Sir, power 3 phase is equal to 3 wattmeters are there, means W1, W2 plus W3 only, obviously, because 3 meters are there, we should take 3 meters compulsory. Clear? Right, sir. 3 phase W1 plus W2 plus W3. Sir, in order to say left and right hand side both are equal, in order to say both are equal, what we should say here? W1 should read single phase, W2 should read single phase, W3 should read single phase. W1 single phase, W2 single phase, W3 also single phase. Then only we can say single plus single plus single 3 times 3 phase power. Suppose if it is measuring 3 phase, for example, so 1 plus 3 plus 1, 5 phase power, but our topic is 3 phase power only. That's why even in the 3 wattmeter method, we should connect each and every wattmeter such that each and every wattmeter should measure single phase power only. Each and every wattmeter should measure single phase power only. That's what the point. Okay. Now again, sir, this 3 wattmeter method is generally useful in which type of loads? Right. What is it? Which type of loads here? Generally what I told you, unbalanced loads. Okay. But few people are giving, sir, both balanced and unbalanced. Yes, but I'm taking unbalanced load. Okay, right. Few people are asking that, sir, if I remove one phase, is it unbalanced? If I remove one phase, that becomes 2 phase. But our system is 3 phase. Yesterday I told you, last point, basic idea I gave you, 3 phases should be there. Then only our system is 3 phase. In the network theory, one phase is failed, what happens? Other phase is failed, what happens? That is different. But our topic is 3 phase should be there. Then only we can measure power. That's why 3 phase power measurement means there should be 3 phases compulsory. 3 phases compulsory. Okay. And a few people are saying that, sir, why not balanced? I will come to that later. 3 wattmeter method, we can go for balanced and unbalanced also, no problem. But unbalanced I'm taking. Sir, why means? Sir, W1, W, W2, W, W3, W. Sir, all 3 loads are nothing but 3 phase system is balanced system. Balanced system means what is it here? Equal power. Therefore, W plus W plus W also same. W1 plus W2 plus W3 also single phase, same only. But for explanation purpose, I am taking unbalanced first. I'll be coming to balance later. Now again, first one, just like the same thing. One is star and one is delta. Star, right? Second one is delta. Right now. So what is star? Clear? Right. Sir, unbalanced means Z1, Z2, Z3. One student asked the question just now, sir, out of 3 phases, if I remove one phase, that is called as 2 phase system. Be clear. But our system is 3 phases should be there. Unbalancing condition should occur. That's what the point. Concentrate. Sir, this is anyway R, Y, B. So how many wattmeters are there? Concentrate, guys. 3 wattmeters. Each wattmeter should measure single phase power or more than single phase power or 3 phase elements. Single phase only. Suppose it is more than single phase, more than single phase, combined phases, then automatically that will become more than 3 phases, means double time you are counting. So therefore, not at all. That's why each and every wattmeter should measure single phase power. Means we need to connect the wattmeter such that phase and neutral, in between phase and neutral. Sir, here also neutral wire I'm drawing with dotted line, right? Suppose neutral is not available. Is this method possible? No way. Again, same limitation. What is it? Star should be with three phase, four wire type. Then only 3 wattmeter method is possible. Otherwise, 3 wattmeter method is not possible. I'm showing the picture. Sir, current coil, potential coil. Sir, phase to neutral. So phase one. Okay. Now, current coil. W3, right? And here current coil W2. Sir, each and every wattmeter connected between phase to neutral, phase to neutral, phase to neutral. Therefore, each and every wattmeter is measuring single phase powers, phase 1, phase 2, phase 3 powers. Suppose if I remove this one, where do you connect these return terminals? Means one phase we have to take. That's why combined phases will become. That is the reason why definitely the unbalanced connection also 3 wattmeter method is also suitable, applicable for which connection here? Star, okay. 3 phase, okay, but 4 wire is compulsory. Fourth wire is compulsory. If fourth wire is not there, we cannot go for this 3 wattmeter method at all. Clear? Same discussion here also. Delta connection. This is R, this is Y, this is B, Z1, Z2, Z3, Z1, Z2, Z3. Okay, right, sir. 1 wattmeter, 2 wattmeter, 3 wattmeter. Suppose if I connect like this, is it measuring single phase power? No. If I connect like this, is it measuring single phase power? No. Suppose if I'm connecting from here to here something, is it measuring single phase power? No. But what is our task now? We need to measure single phase power only. We need to measure single phase power only. Sir, how means what I told you in the earlier discussion? Sir, one branch of the delta must be open to connect the 1 wattmeter to measure the single phase power, thereby to calculate the 3-phase power. But sir, here 3 wattmeters means we should be able to remove 3 loads. Is it possible practically? No. But diagrammatically I'm showing current coil W1, right? Current coil, potential coil, this is W2, and current coil and potential coil W3, right? Okay, diagrammatically possible, but on the screen, what did I do? Simply I erase like this. Erase means practically we opened the load, but actually we have seen, sir, one load itself is not possible to be opened by the operator. How can you open the 3 loads here? No way. That's why 3 wattmeter method also, 3 wattmeter method also not universally acceptable. What is the condition? 3 wattmeter method also. How many wires we require? Fourth wire is also required. If fourth wire is not there, we cannot get the power. Okay. In the same way, what is that? Delta connection also. In order to connect the 3 wattmeters, 3 loads must be open. Already I told you, load you cannot open. Load you cannot open. Even after opening that, no use, time waste, nothing more than that. That's why, strictly speaking, as an operator, you should not open. If any problem is there, you should call the corresponding person to have that entire thing. That's why we should not open. Now tell me, whatever the discussion I've taken, 1 wattmeter method or 3 wattmeter method are universally acceptable methods, or condition based acceptable methods means condition based only, not the universal acceptable. Why? I'm repeating here. Kindly concentrate. total discussion repeating as it is new to many people. Here, balanced one, 1 watt meter, right? In order to connect 1 watt meter to measure the single phase power, thereby to calculate the three phase power, automatically fourth wire, neutral wire is required. Neutral wire is possible in three phase, 4 wire system, but three phase, 3 wire system also there, not possible. Next, in the delta connection, 1 watt meter should be connected such that single phase power must be measured, thereby multiplying with 3 phase power must be calculated. But in order to have that, one load must be open in the delta connection, not possible. That's why not universal. Next, sir, 3 watt meter method in the unbalanced connection, 3 watt meter method in the unbalanced connection, right? What is that? Star connection, fourth wire is compulsory to get single phase 1, single phase 2, single phase 3. Then we can say, yes, right hand side, left hand side, both are equal, we can say. Therefore, fourth wire is compulsory. Fourth wire is possible only in 3 phase, 4 wire connection. Okay, delta connection. So in delta connection, what will be there? In order to connect the 3 watt meters, right? To measure the 3 individual phase powers, yes, single phase 1, single phase 2, single phase 3, like that. In order to measure all these things, 3 loads must be opened. But already we face problem with single load open. How can you open the 3 load here? Never. That's why 3 watt meter method is also not universal. It is condition based. Okay. Now I'll give the summary also. I will revise again. Don't worry, sir. Now, what I told you in the introduction of power measurement: 1 watt meter method, 3 watt meter method. Next one is 2 watt meter method. So therefore, I'm taking 2 watt meter method. Right. What you have to understand, if you understand this key point, yes, measurement of three phase power will be very, very simple. What is that? Power three phase is equal to which one here? W1 plus W2. 2 watt meters are there. W1 plus W2 is three phase. Now concentrate. Left hand side and right hand side should be same. Means each and every watt meter should measure single phase power or more than single phase power. Come on. Right? Very good, very good. Simple mathematics. Right? Left and right hand both should be equal. Soundarya, if it is measuring single phase power, it is also measuring single phase plus single phase, 2 phase. But we should get which one here? 3 phase. Therefore, left and right hand side not equal. So that is the reason why we need to connect the watt meter in the circuit such that not single phase power, it is more than single phase power. It should measure. Right. Who is this? Amit Vikram. Right? I will tell you. I have not started. Only just introduction I give you. How it is be done. Wait. How will it be done? I will tell you. Right? Concentrate. So more than single phase power, it should be. Right. Sir, concentrate. It is measuring single phase. What is it? 2-phase power only. But we need to measure 3-phase power. So that is the reason why each and every watt meter should not measure the single phase power, should measure the more than single phase power. First task. Okay. Right. Now I'm taking first one. Star. Very, 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 very important concept. This only concentrate. Earlier, 1 watt meter, 3 watt meter is actually introduction only that to this entire topic. Earlier, whatever the thing we have taken for almost 45-50 minutes, that is introduction to this 2 watt meter method. But I have taken elaboratedly. Clear? Okay. Now, in the star connection, what I'm taking, Right. Sir, R, Y, B. First point here, this may be balanced or unbalanced, no problem. You can use this for balanced or unbalanced, no worries. Okay, now the question is, sir, neutral wire we should take or we should not take? Neutral wire. Be clear, guys. If neutral wire is there, what is it here? 1 watt meter method is possible. If 1 watt meter method is possible, why do we try for 2 watt meter method? Unnecessary measurement cost extra. That's why if you are going for 2 watt meter method means, neutral wire should not be there. Sir, without the neutral also, we are going to measure three-phase power with the help of 2 watt meter, such that concentrate. Sir, I am connecting current coil. I am connecting potential coil here. Sir, this is measuring single phase power or more than single phase power. Means more than single phase. Why? See, potential coil is connected to two phases. Current coil is connected to two phases. Means more than single phase. Okay. In the same way, sir, current coil and potential coil here. Sir, this one W2. This one W2. Here also, sir, current coil related to two phases and potential coil also related to two. Means what is our requirement? More than single phase only to be measured. Then only here, if it is single phase, I told you, I'm repeating, single phase, for example, single phase plus single phase, two phase only, but we should get three phase. So that is the reason why we need to concentrate on, which one here? More than single phase power is to be measured by 1 watt meter and other watt meter also 2 watt meters. Then we can say yes, three phase. But here doubt will be there. So how can you say W1 plus W2 equal three phase? We are going to start the topic. I am going to give the proof and then we'll be solving the various number of questions in this topic. No need to worry. But conceptually, more than single phase, yes, there may be a chance of, yes, three phase power, correct. That's what the point. Okay. Now, sir, delta connection I'm taking. In delta connection, without opening the loads, if it is possible, we can say, yes, this method is universal method because in the delta connection, three loads we tried to open, not possible. One load we tried to open, but not possible technically, practically. But in this, without trying to open the load, because we cannot open the load, and with the 2 watt meters, if we are able to measure, three phase power, yes, definitely universal method we can say. Possible or not? Let us see now. Sir, delta connection. I told you. Delta connection structure like this. Like this. This is R. This is Y. This is B. R, Y, B. So impedance Z or Z1, Z2, Z3, anything, no problem, anything, right? Here, sir, I don't want, actually not I don't want to, we cannot open the load, okay? Without opening the load, 2 watt meter should be connected such that, what is it? More than single phase, combinedly equal to three phase should happen. Simply current coil, potential coil. Sir, this is measuring, sir, potential coil is across one phase, okay, but current coil is carrying all the phases, means more than one phase power is there, okay, over. Second one, current coil is here, potential coil is here, anywhere, just two cases I'm taking. W2. Now tell me, by looking at these two connections, can we say 2 watt meter method is universal because neutral wire need not to be present, yes, over, and delta connection need not to open the load. So now tell me, 1 watt meter method, fourth wire is compulsory, yes or no? Our delta load must be open. 3 watt meter method, fourth wire, neutral wire is compulsory. 3 loads must be open. But in the 2 watt meter method, neutral should not be present, not required. and delta star connection, neutral not required, delta load need not to be open. Automatically what we can say, 2 watt meter method is the universal method, right? Actually, I have spent almost 1 hour of time in this basic only to inject the electrical points very much clearly. Otherwise, 1 watt meter, 3 watt meter not there for you. 2 watt meter method, take it for granted, but it will not be clear. Throughout the entire topic, some doubt will be continued. That's why with the figures I have explained. So kindly concentrate. Right? This is the total discussion regarding this. Now, sir, very good, very good. Which method is universal method? Obviously, 2 watt meter method is universal method, undoubtedly. Undoubtedly, 2 watt meter method. Right. Vishnu, very good. So if 2 watt meter is universal, then why to study 1 and 3 watt meters? After studying 1 and 3 watt meters only, we came to know the drawbacks and we are trying to overcome with the 2 watt meter method. That's what the point. You're asking like this, sir. MI instrument is not preferable for DC. Then why did you study? Don't study means, come on. No, that's what. Why it is not possible, how it is not possible, definitely we need to study. Okay, right, Vamshi. Yes, balanced or unbalanced, no problem. Why? Here, only connection-based problem is there. In the earlier method, balanced and unbalanced, no worries, because it is not connected to each and every load. It is connected to combination of the loads, That's why it is suitable for both balanced and unbalanced universally. This is the complete introduction of my three-phase power measurement chapter. Now I'm going to start which one? 2 watt meter method. Why? 1 watt meter method we don't prefer, not acceptable universally. 3 watt meter method also not acceptable universally. But before going to the entire method and all, I'm giving one summary here. What is it? Concentrate. That is Blondel's theorem. Blondel's theorem. Nothing but whatever the discussion we have taken so far, 1 watt meter suitable or not suitable, 3 watt meters suitable or not suitable, 2 watt meters suitable or not suitable, the entire concept is given by which theorem? Blondel's theorem only. Whatever the discussion you have taken, that is given by which theorem? Blondel's theorem only. Blondel's theorem. Clear? Right. Concentrate, sir. What is Blondel's theorem? The Blondel's theorem actually simple. It states that the number of watt meters required, to measure three-phase power. It states that the number of watt meters required to measure three-phase power. Yes, in the 1 watt meter method, 3 watt meter method, and 2 watt meter method, that only we have taken. 1 watt meter method is suitable when I'm repeating so many times. Concentrate. 1 watt meter method is suitable when balanced fourth wire in the star is required. In the delta, one load must be open, not possible. 3 watt meter method is used when in the star connection, neutral wire is required, fourth wire is required, but may not be practically, so not universal. In the delta connection, 3 loads must be open, not possible. That's why 2 watt meter method is need not to worry about neutral, strictly speaking, not required. And in this, 3 loads or single load need not to be open. Either 1 load or 3 loads need not to be open. So automatically, yes, you can go for 2. That's why the universal method is the 2 watt meter method. The universal method is the 2 watt meter method. Clear? Right. I'll be giving some summary here. What are the things we have taken? No, that entire summary in one table I'm showing. In one simple table. Kindly wait for 1 minute. Right? I'm taking one table. Just 1 second. Right. I'm taking one figure to understand more clearly. Concentrate here. Sir, I'll explain each and everything. Concentrate. Sir, three phase, three wire. So what do you mean by three phase, three wire? Automatically star connection only. Three phase, three wire means automatically star connection only, because delta connection, there is no question of fourth wire. Three phase, three wire means either star or delta. Anything is possible. Okay, now concentrate. Here, balanced, unbalanced load, balanced load, unbalanced load I have taken. Kindly concentrate. Sir, three phase, four wire. Everyone kindly look at me, concentrate. Three phase, four wire. The moment four wire means fourth wire is there. Fourth wire is mean neutral wire is there. Neutral wire is there means 1 wattmeter method is possible. 3 wattmeter method is also possible. Why? 1 wattmeter connected between phase and neutral into three phase power. But what is it? 3 wattmeter means phase to neutral, phase to neutral, phase to neutral. 3 wattmeters are possible. That's why minimum number 1, maximum number 3 I'm giving. In the same way, so 3 phase, 4 wire, unbalanced system. So unbalanced system means what is it? Z1, Z2, Z3 are all are different. All are different. If all are different, right? Is it possible to use 1 wattmeter? No. Why? Unbalanced. Z1, Z2, Z3 different. 1 wattmeter we cannot go. And fourth wire is there. Neutral wire is there. Do you go for 2 wattmeter method? No way. Only which one here? 3 wattmeter method only. That's why minimum is 3, maximum is also 3. I have taken so total discussion so far. I'm giving as a summary. And three phase, three wire. Three phase, three wire means either star three phase, three wire or delta anyway three phase, three wire only. Okay, balanced. Balanced. Sir, three phase, three wire. Concentrate. If it is a star connection, neutral wire is not there. If neutral wire is not there, 1 wattmeter not acceptable. Neutral wire is not there. 1 wattmeter not acceptable. As well as neutral wire is not there. 3 wattmeter also not possible. Why? 3 wattmeter means W plus W plus W. Neutral is not there, not possible. That's why only one is possible. 2 wattmeter. Minimum is 2. Maximum is also 2 only. Okay. Next, unbalanced also same thing. Sir, unbalanced star, three phase, three wire means neutral wire is not there, but unbalanced. Unbalanced means one is not suitable. And neutral wire is not there means 3 is also not suitable. Automatically 2 only. Minimum 2, maximum 2. Delta also same thing. Whatever I have taken 1 hour of topic, I am giving as the simple summary. This is the total discussion to start the 3-phase power measurement by the 2 wattmeter method. Clear? And one more thing. People are asking this question, general doubt. Sir, suppose if I have the neutral wire like this, sir, can I go for 2 wattmeter? No. If neutral wire is there, automatically which method? 1 wattmeter method is satisfied. You can go for 1 wattmeter. Second thing, sir, neutral wire is there, but I don't use. Can we go? No. Neutral wire is given by the manufacturer means neutral wire must be the written path. But written path here, you are keeping open. So that's why the important note here is I'm giving now here. If neutral wire is present, if neutral wire is present, 2 wattmeter method is not used. Then 2 wattmeter method is not used. Why? Neutral is there. neutral should act as return path. But in this, something else is acting as the neutral path. That's why if neutral is there, blindly we go for 1 wattmeter method for a balanced system. Example. So this is the complete summary, right? Actually, openly speaking, now I'm starting my measurement topic. So far I have taken, that is simply basics. Without that also, I can take this one, take it for granted, remember, etc. But I explain totally, kindly concentrate on one by one. Clear? Right. Now, let me start 2 wattmeter method. Each and every topic I explained almost 4-5 times. Star connection balanced, star connection unbalanced, delta connection balanced, delta connection unbalanced. I explained so many times. And conclusion also I gave you. Right. 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 See, if neutral, that is the point here. If neutral wire is there, forget about the 2 wattmeter method. People are asking, sir, in the 2 wattmeter method also, if I connect the neutral wire, actually 2 wattmeter method, when you have to prefer, when the neutral wire is not there. If the neutral wire is there, 2 wattmeter method is not applicable. Why? Means 1 wattmeter is already possible. No, that's why we should not come to 2 wattmeter. That's what the actual point. Right. So if neutral is available, see, unbalanced, I told you 3. Unbalanced, I told you 3. If neutral wire is there, come on here, already told you here. If unbalanced is there, neutral is there, minimum itself is 3. That's why check it here. Unbalanced is there, neutral is there, minimum 3. 1 is not possible. Anyway, 2 wattmeter cannot be used. Why? 4th wire is there. So minimum 3, maximum 3. So that's why be clear with the terminology. As it is completely new to you, it may be a little bit doubt, but I have given all types of explanations. Right. Ankur, ask your network theory faculty. Okay, right. Sir, Blondel's theorem itself is, I gave you, why are you asking again and again? Blondel's theorem states that the number of wattmeters required to measure the 3-phase power. So this is the total Blondel's theorem result. 1 minimum, 3 maximum. Which theorem? Blondel's theorem only. Blondel's theorem only. If neutral is available, 1 phase and 3 phase is used. What is 1 phase and 3 phase? 1 wattmeter and 3 wattmeter, I think. You guys, yes. If neutral is there, we should not go for 2 wattmeter method at all. Right. Now, let me take. Again, yesterday I praised, people did not type while I was explaining. Again, you came back to your original behavior. Again, typing. That's why I'm leaving all the questions. Right. 2 wattmeter. Those who have concentrated on my topic, it is clear. Other people, those who typed along with my explanation, will not be clear, cannot be clear in your lifetime. Leave it. Okay. 2 wattmeter method. Sir, in this 2 wattmeter method, for explanation purpose, I am taking star connection because our duty is not to study the 3-phase circuit. Our duty is to study the 3-phase power measurement. 3-phase power measurement. That's what the point. Right, Vashishta, correct. You listen carefully, you understand this. Very good, very good. Right. Instrumentation people, whatever I have taken, kindly go through all those. That itself is the total topic in the measurement subject. Right? Okay, now, at least no, right? Don't type the questions along with my explanation. At least no. 2 wattmeter, sir. For example, star. Sir, why only star? No, nothing, no rule at all. One of the connections I'm taking. Load, I have taken lagging sometimes, leading sometimes, resistive, like that. Here also star I'm taking, for example. Sir, this is the star connection. Right? Star connection. Sir, this is R, Y, B. Explanation purpose only, I am taking Z, Z and Z. Balanced I'm taking. But numerically, I am going to take unbalanced system questions also. Don't worry. Only explanation purpose I'm taking balanced. Okay. Right. Explanation of the total three-phase system. Total three-phase system. I'm taking the neutral wire. But don't think like, sir, two-watt method, neutral. No, only to explain the three-phase concept I'm taking. After that, I will erase this line, no need to worry. Right? Okay. Now, the first terminology, everyone, especially IN people, electrical people already know this, but it is just like a revision to you. But IN people concentrate. Sir, here, whatever the current we define at the terminals IR, IB, IY, IB, IY. These currents are called as IR, IY, IB are called as line currents. Nothing but whatever the value we are defining at the terminal, that is called as, what is it? Line current terminology. Suppose, sir, same current is coming here. One phase IR. Same current is coming here. One phase IB. Same current is coming here. What is it? IY. Sir, phase current IR, phase current IB, phase current IY. So therefore, in the star connection, line current is equal to phase current. First point. Electrical, many of the cases in your machines or power systems, you might have taken this. But I'm repeating this because if I prove this, you can understand the next topics clearly. Simple mathematics only. Okay. After that, sir, I'm defining voltage across this phase to neutral, means VR to N means V phase. VR to N means V phase, because one phase, one neutral. Okay. Next, here I'm taking V B to N. I'm taking V B to N is also, what is it here? V phase only. And here I'm using V Y to N. It is also V phase only. Clear? So therefore, what we can write now, sir? VRN, VYN, VBN is equal to which value? V phase. You may be getting the doubt, sir, why all are equal? I have taken balanced for understanding purpose. People are asking, sir, explain in unbalanced case. Suppose if I want to explain unbalanced case, Z1, Z2, Z3, which will be more, which will be less? Based on that, we need to measure which is more length, which is less length. That is not possible. That's why concept always explained for balanced loads. After that, numerical questions and all will be taken for unbalanced. No need to worry. Okay. After that, final terminology. Sir, here V R to Y. All I told you, at the terminals, if you define the at the terminals, if you represent, those are called as line values. So therefore, what is it? R to Y. So VRY is equal to VL. VRY is equal to VL. After that, I'm going from Y to B. VYB is equal to VL. VYB is equal to VL. After that, again, B to R. What is it? VBR is equal to VL. Means what sequence I have taken? RYB, RYB, RYB. Means here RY, YB, BR, the terminology. R to Y, RY, Y to B, YB, B to R, cyclic process. So all these are which one here? Line voltages. Okay. VRY, VYB, VBR is equal to V line. Sir, in the star connection, by the circuit only I have put that line current is equal to phase current. That's why from now onwards, wherever you get star connection, line and phase currents both are same. Line and phase, and line means at the terminals. Phase means through the load. Both are same in the star. But in the star, sir, VRN, VYN, VBN, these are the phase voltages. VRY, VYB, VBR, these are the line voltages. These are the line voltages. Sir, what about these two relation? Same or different? These two are same or different. That's what I'm writing here. Very important. VRY, VYB, VBR, VRY, VYB, and VBR. Sir, what is this? Concentrate. Sir, R to Y means start here. R to N, N to Y. R to N, N to Y. So therefore, what is it here? VRN plus VNY. VRN plus VNY. In the same way, sir, VYB, Y to N, N to B. So therefore, what is it? VYN plus VNB. In the same way here also. VBN plus VBN plus VNR. 1 second. Right, tell me. Here, VRN plus VNY, VYN plus VNB, VBN plus VNR. Now tell me, sir, how do we modify this further? Sir, RN always be clear in the electrical circuit point of view. First letter is always phase. Second letter is always neutral. Written path. Phase, written path. But here first letter is neutral. Is it possible? No, that's why we have to reverse it. How? Very simple. VRN. NY should become as YN. So simply minus VYN. But don't forget this is vector, because AC system, no, positive vector, we are reversing negative vector. Here also VYN minus VBN. Here VBN minus VRN. Clear? Now tell me, sir, phase voltage, combination of phase voltage is equal to line voltage. That's why what we can say with this, sir, line voltage is not equal to phase voltage. But what is this value? I'll tell you. But both are not equal. This is a complete three-phase basics I have given to start my 2-watt meter method. So far also I have given basics only. Now I'm starting my 2-watt meter method, because in the syllabus also measurement of three-phase power by 2-watt meter method only generally. But why we are going for 2-watt meter method? Why not? Why we are going for 2-watt meter method? Why not the 1-watt meter, 3-watt meter? You need to have the, what is that concept that's explained. But before going to the 2-watt meter method measurement, you need to have three-phase basics compulsory. What is line, what is phase, and all. That's what I have taken. Clear? Now I'm starting my topic. What is that? 2-watt meter method. Where do we connect 2-watt meter here? Where do we connect 2-watt meter? Concentrate. Here, 1-watt meter I'm connecting here. Okay, and current coil, potential coil, concentrate. I'm not using the neutral wire. Actually speaking, neutral wire is not there. But only to explain this entire concept, I have taken neutral point. I have taken wire is not there. Wire is not there. Wire is not there. That's why be clear. Once you are going for 2-watt meter, automatically neutral wire should not be there. Point will be there inside. Means suppose if the box is there like this, RYB, internally neutral point will be there, but wire is not brought outside. What does it mean? You can take any wire as the written path according to our convenience. Yes, I'm taking that only. Yes, I'm taking that only. And one more wattmeter I'm connecting here like this. This is W2. This is W1. Clear? Okay, now people are getting doubt. Sir, why are you connecting R to B? Why not B to R? That is your wish. One of the connections I'm showing. Second one. Sir, why Y to B? Why not B to A? That is your wish. No problem. One of the connections I'm taking. But what is it? Sir, this wattmeter measures combined phase power. This wattmeter measures combined phase power. But if we add these two, W1 and W2, we are going to get perfectly three-phase power. I'm going to prove now. Okay, right. Now concentrate here. Right, concentrate, guys. So in this entire wattmeter connection, be clear, guys. What is W1? What is W2? Everyone concentrate. We have taken the concept also in the corresponding wattmeter notation. What is that? Potential coil voltage into current coil, current into cos of angle between those two. That's what wattmeter reading or not? Check it. So W1, everyone keenly observe the circuit. So W1, potential coil is between R and B. Where you are connected? Between R and B. In my example, so why not VBR? You reverse the connection. That is different. But in my example, I'm giving R to B. So therefore, VRB. Okay. Current coil is in R phase only, IR only, IR only. So therefore, IR. After that, cos of angle between VRB and IR. VRB and IR. Now, everyone, I'm repeating with the second wattmeter. Concentrate. W2, potential coil is connected between Y and B. Y and B. So therefore, what is it? V, Y, B. Okay, next. Sir, current coil is connected in R phase only. Yes, this is completely R phase. Sorry, Y phase. So this is Y phase. So therefore, I, Y into cos of angle between VYB and IY. Consider, guys, if you are able to write these two values by looking at the given circuit in the question, thing will be done. That's why it is very important thing. That's why I'm repeating. Concentrate. Sir, in my circuit, kindly don't ask the question like, sir, if I change the wattmeter connection, you change it, you draw it, you write it, you will get it. Don't worry. That's a concentrate here. Sir, potential coil R to B. So VRB. Current coil IR. IR cos of this one. And wattmeter 2. Potential coil YB. VYB. Current coil IY. Current coil IY. Angle between those two. Okay. Now the problem is, sir, this is which voltage? Line voltage. Sir, what is this line voltage into phase voltage? VRN minus VBN. So how are you writing? I told you here. Simple shortcut I'm giving. RY is there, no? RN minus YN. Simple shortcut. Here. YN minus BN. I gave by explanation, I'm giving the shortcut. That's why RB is there. R first letter, VRN, minus B second letter, VBN, over. Here again, VYB means what we can write? VYN vector only, minus VBN. Clear? Now after this, now I'm going to take phasor diagram. Kindly concentrate. Phasor diagram I'm taking. But by assuming lagging load I'm taking. By assuming lagging load I'm taking the example. Sir, what is that? What is it? So why only lagging? Why only lagging? I'll tell you. Leading also after this. No need to worry. You can understand resistor load properly. No problem. Right. Here. Sir, what is a phasor diagram? Concentrate. Sir, I'm taking. This is VR. This is VRN. I'm taking R by B phase signal. So I told you VRN. and VYN. VBN. Sir, why 120, 120, 120? Each with each other means which one here? 120, 120 means which one? Balanced system. I'm taking balanced only explanation purpose. Okay. After that, sir, which load? Lagging load I've taken. So therefore, sir, this is IR. What is this angle? This angle is phi. Some phi. 36, 46, 45, something. IR lags the VRM. This is IY lags the VYN because phase current lags its own phase voltage by phi, and IB lags by VB. Okay, lagging load we have taken. After that, sir, in our discussion, VRB IR cos. If you are knowing all these, we can get the W1. Sir, IR already there. What we require now, sir? VRB we require. How do you get VRB? VRN minus VBN. Add these two vectors. Okay, VYN minus VBN. We need to combine. Sir, minus VBN minus VBN. In our diagram, it is not there. We need to bring it. What is that? Constant. Sir, VBN is there now. I'm reversing this one. I'm reversing this one. What is this? This is minus VBN. Okay, VBN, I reversed it. Now check it. Sir, I require VRN. It is there. I require minus VBN. It is there. So automatically, kindly add these two vectors. Parallelogram law procedure. Like this. Sir, finally, what is this? This is VRB. Okay, what we require? VRB we require. We got it. Leave it. Sir, second wattmeter. VYN already there. Minus VBN also already there. So therefore, VYN minus VBN simply take like this. VYN minus VBN. Right? And finally, combination should be, what is it? No. What is this here? VYB. Okay. Now go back, sir. VRB we obtained. IR already there. VYB we obtained. IY already there. So therefore, now our duty is to find out angle between VRB and IR, angle between VYB and IY. So simply concentrate here. I am taking here. What is that? VRB and IR. We require this angle. Sir, this angle is which angle? VRB and IR. W1 wattmeter one angle. So therefore, W1 related angle. Okay, next. Sir, VYB and IY also we require. So therefore, VYB and IY. So this angle we require. So therefore, this is W2. This is W2 angle, not wattmeter. Wattmeter angle. Okay, now after getting this entire thing step by step, I'm revising now. First take phase voltages VRN, VYN, VBN. Next lagging load, no, IR, IY, IB. After that, go to the wattmeter connection according to the given circuit. Assume that this is a question. In this question, it is given. Follow this only. According to the question, we need to draw. That's why concentrate here. VRN already there. VBN is there, but we require minus VBN. Reverse it. Combine this VRB. Combine this VYB over. Nothing more than that. But unless and until you practice this phasor diagram on your own by writing with your hand, you will not get it. If you, even after the class, if you are reading this, it will be clear. It will be clear. But if you draw it again, then only it will be more and more clear. That's what the point. Okay. Now concentrate here. 1 second. Sir, now I'm taking. So W1 reading. W1 reading is which one? VRB. Sir, VRB or VBR? Both are same in magnitude or different in magnitude? VRB or VBR? Both will be same in magnitude or different in magnitude? Same only. Only direction is different. So therefore, VL. Why? Check it here. VRB, VBR. VBR is nothing but simply VBR. Which one? V line. So simply line voltage. After that, sir, IR. What is IR? IR is line current or phase. Whatever you require, you can take it. I am taking this as IL cos of dash. Again, W2 VL IL. Sir, why? Check it. VYB line voltage. IY line current or phase current. Anything we can take. I'm taking line current. And finally, cos of angle. Everyone see the phasor diagram. See the phasor diagram. Concentrate. Sir, what is this angle? What is this angle? This is not electrical basics. This is not BTech level. This is simply a mathematics school days topic. What is that? Finding the angle. I have given the diagram. Find the angle. That's it. I'm explaining. Concentrate here. Concentrate. Sir, here to here 120. Yes or no? Here to here 180 because straight line. So therefore, here to here 60. Okay, sir. If this is 60, automatically it is parallelogram. No, this will be 30. This will be 30. It is not by electrical BTech concept. No, it is simply 9th class, 10th class concept. Because up to the diagram, our topic. But after giving the diagram, find the angle, normal topic. Be clear. What is that? 30 and 30. So therefore, if this is 30, we require only this one, 30 minus 5. So therefore, this will be 30 minus 5. Still doubt is I'll come with other thing. I will come with other point also. I'll come with other point also. What is that? Concentrate. Sir, 120 because it's a balanced system. 180. So no, because it is a straight line. Now, this will be 60. 120 plus 60, 180. This will be 30 because equally divided. Why? Balanced. Now tell me, if I would have taken unbalanced like Z1, Z2, Z3, now tell me which should be drawn more length, which should be drawn less length. This is 60 means this is 38, 22, 35, 25. We cannot, and that's why in the conceptual point of view, every time we take balance only numerically, we know Z1 equal to 5, Z2 equal to 6, like that will be given. We can proceed over there, don't worry. That's why, sir, as this is 30, 30 plus 5. So this will be 30 plus 5. 30 plus 5. Clear? So therefore, no substitute here. What is this? VLIL cos 30 minus 5. VLIL cos 30 plus 5. 30 minus 5, 30 plus 5. Okay, sir, this entire thing is for which load? Lagging loads. We have got it by the electrical basics. By the electrical basics. Now tell me what will be the W1 and W2 for leading loads. So lagging to leading, which will be changing? Lagging to leading, which will be changing? Come on, guys. Lagging to leading, which will be changing here? Minus 5 becomes plus 5. Plus 5 becomes minus 5. So simply direct shortcut. What is that? VL IL cos 30 minus 5 become plus 5. VL IL cos plus 5 becomes minus 5. This is for leading. That's why in the electrical engineering, one advantage is that once you study the lagging load, exactly opposite direction, leading load. In the yesterday's class also we have taken, what is that? Error was plus for lagging loads, minus for leading load, because exactly reverse. Here also same thing. But few students are asking that, so how this is 30 plus 5? That is 9th class topic. I told 9th class topic, 10th class topic. But I explained. But still, I'm explaining again. Concentrate. Sir, this is 120. Okay. This is 160 because straight line. Therefore, this will be 60. And by 2, this will be 30. Check it here. This angle is 30. We require here to here. What is it here? This is 30. This is 5. What is the angle here? 30 plus 5. 30 plus 5. Got it? Right. Very good. Now tell me, either you add these two or you add these two. Are we going to get same power or not? Why? W1 plus W2, W1 plus W2, both will be same only. So that's why now I'm starting the mathematical analysis. First point. Sir, first one, W1 plus W2 I'm taking. What is W1 plus W2? VLIL cos 30 minus 5 plus cos 30 plus 5. Because I have added these two. VLIL common, these two added, these two, no problem. Because A plus B or B plus A, both will be same only. Clear? Okay. Now again simple mathematics. VLIL. Sir, cos C plus cos D, you'll be getting 2 cos 30 cos 5. What is cos 30? Root 3 by 2. 2 will be cancelled. You will be getting root 3 VLIL cos 5. Now tell me, sir, in our 2 watt meter method of connection, 2 watt meters readings are being taken. Have we got the actual 3-phase power value or not? Yes. Now, few people ask that by taking this, sir, actually, sir, this watt meter measuring these two phases, this watt meter measuring these two phases, sir, this is double time measured. No problem, no problem. That is what I have not answered that question so far. Now I'm answering with proof. Sir, W1 reading I have taken RB combination, W2 reading YB combination. Still the total power addition of this is coming as which one here? 3-phase power only. At least now I got the confidence here. 2 watt meter method, yes, we are getting root 3 VLIL cos 5 means automatically 3-phase power only. Okay. Now, sir, I'm writing root 3. Sir, IL is equal to I phase because our example star connection into cos 5. Sir, what is VL in terms of V phase? We know VL is not equal to V phase, but what is that value? Yes, I'm doing now. So in this phasor diagram, concentrate guys. Sir, here this is VL, this is V phase, this is also V phase. I hope everyone knows parallelogram law formula. What is parallelogram law formula? VL square is equal to root of physics parallelogram is what is it? C square equal to or C equal to, one second, VL is equal to root of C equal to root of A square plus B square plus 2AB cos of same thing. Sir, V phase square plus V phase square plus 2V phase, V phase. Sir, V phase and V phase angle is how much here? 60. I told you cos 60. If you simplify this, you will be getting VL is equal to root 3 V phase. I'm not skipping anything, each and everything I'm noting down. VL equal to root 3 V phase. That's why in the star connection, line voltage is not equal to V phase. Okay, line voltage is equal to root 3 times of V phase. Root 3 times of V phase. That's what the point. Clear? Right? Now, here, what we can write now? Root 3 times of V phase. So root 3 into root 3 V phase, I phase, cos 5. At least now got it? 3 times of phase power, 3-phase power. That's why 2 watt meter method is universal method where what is a neutral wire is not there. Yes, we are using the two neutral wire. Problem itself is not there. We can measure it. But how do you have to connect? R to B, Y to B. Otherwise, R to Y, B to B. Like that you have to connect. Automatically, you are going to get 3-phase power. Now I'm writing like W1 plus W2 is equal to which one here? Now I have not written here. Now I'm writing power 3-phase. Now I'm writing power 3-phase. What is the name of this one? Active power. Clear, got it? consumed power itself is always active power only as power 3-phase. That's why with the 2 watt-meter method, are we able to get 3-phase or not? Yes. Now, if any doubt is there, sir, it is double time measured, no problem. That is what the connection method. Still, we are getting same 3-phase, no headache at all. So this is the 2 watt-meter method of power measurement, but not completed. Sir, this 2 watt-meter method has not only one advantage. 2 watt-meter method has so many advantages. So many advantages. What are those? Means if I'm giving 2 watt meter readings like 1000 watt, 2000 watt, simply add those two to get the 3-phase power. This is the proof. Suppose people are asking, sir, I have 2 watt meter readings. Can I subtract? Yes, you can subtract. Second one, W1 minus W2. Don't get confused like, sir, why are you subtracting? I too don't know in this batch. I too don't know. Let us verify what we are getting. Means simply, I'm giving A and B. You can play with them. A plus B you can do, A minus B you can do, or A minus B by A plus B, anything you can do. But if you do A plus B, what we got? Perfectly 3-phase power we obtained. Okay. If you subtract that, what do we get? If you subtract that, what do we get? Let us analyze. Let us analyze. What is that? W1 minus W2. W1 minus W2 is what is that? VLIL cos 30 minus 5 minus cos 30 plus 5. Nice, sir. VLIL cos C minus cos D, you'll be getting 2 sin. Sir, sin 32 cancel. What is it here? VLIL sin 5. What is this? W1 minus W2. I hope everyone knows this. Sir, cosine is there, cos phi. Cosine is there, cos phi. Sine is there. What is it? Cosine is there, cos phi. Cos phi means active power. Sine is there, which one here? Reactive. So simply it is called as reactive power. Means with the 2 watt meter method, not only active power, but also reactive power. But is it 3-phase? No. Next, third one. Sir, I want to multiply with W1 minus W2 value. Sir, why? I don't know in this batch. I'm verifying. Just simply trial and error method I'm taking. We are getting something. We are noting down. Root 3 times of VLIL sin phi. Sir, root 3 VLIL sin cos phi means active power. Root 3 VLIL sin phi means reactive power. Now I can write Q 3-phase reactive power only, but 3-phase reactive means if we have 2 watt meter readings, we can play with them. Active power we can measure, reactive power also we can measure. Okay, and people are asking, sir, is it not average? Come on here. V phase, VRMS, I phase, IRMS, cos phi, VRMS, IRMS, cos phi, automatically average only. But their average RMS comparison, so I used average word. Here, active and reactive comparison, I'm saying that active and reactive, but always wattmeter gives average power only. Clear? Next. So not only this, fourth one I'm taking. What I'm taking, W1 minus W2, W1 plus W2 I'm taking. Why? I don't know. I'm openly saying I don't know as of now in this batch. Let us verify. So what is W1 minus W2? VLIL sin phi. Let us substitute. VLIL sin phi by W1 plus W2, W1 plus W2, root 3 VLIL, anything you can take. I'm taking this. Root 3 VLIL cos phi. Okay. After that, sir, IL cancel. So what will be there now? 1 by root 3 sin phi by cos phi tan phi. Okay. Now, sir, from this, therefore, tan phi is equal to root 3 times of W1 minus W2 by W1 plus W2. Clear? Right, sir. From this, phi is equal to tan inverse root 3 W1 minus W2 by W1 plus W2. What are there with us? W1 value is there with us. W2 is value there with us. If we are having W1, W2 values, with the help of this formula, we can measure which one here? Power factor angle also. We can measure power factor angle also. These many advantages are there with 2 watt-meter method. Not only neutral problem, not only load opening problem here. Apart from those, these many active power, reactive power you can measure. Okay. One more thing I would like to say. Sir, after this active and reactive, one more thing I'm adding here. Sir, apparent power, can we measure? Just I'm giving idea also, all three powers. Apparent power is also possible. What is apparent power? S3 phase is equal to root of power 3 phase square plus Q3 phase square. So if we simplify that, what is power 3 phase? Root 3 VLIL cos phi. Q3 phase root 3 VLIL sin phi. If you take it square and root, finally you will be getting root 3 VLIL. Means with this 2 watt-meter method, we can measure all powers, active power, reactive power, and apparent power also. After that, let us take this one. Okay, power factor angle also possible. Sir, after getting the power factor angle, can't we determine power factor value? Or why not? Sixth one, power factor is equal to cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. This is the power factor. Means if 2 watt-meter readings are there, we can determine, we can measure power factor of the load also. So W1, W2, yes, 1000, 2000, something is there. Substitute there, get the power factor also. These many advantages are there with which one here? Correspondingly, 2 watt-meter method. Okay, and sir, can we take W2 minus W1 also? No problem. You are getting negative sign. No, negative sign means be clear. One sign of power is absorbed power. One sign of power is delivered power. But in the measurement, absorbed or delivered, no need to worry. That you study in your synchronous machines. Active power absorbed, active power delivered, reactive power absorbed, reactive power delivered. That is not required. Our purpose is only magnitude calculation. Don't worry. Okay, sir, in one of the earlier gate papers, right, 2 watt-meter method is used to measure the power in a three-phase circuit. Okay, the power factor obtained by the 2 watt-meter method is dash. Direct formula was the question in the previous gate paper. Direct formula was the question, but out of 4 options, this formula is not there. Something is given, 1, 2, 3, something is given. Fourth option is given as none of the above. Means this formula we have got by taking this lengthy explanation, isn't it? But this formula is not there. This formula was not there. Out of 3, fourth option is none. People are thinking that, okay, this is not there, none of the above. Okay, is it? No, no. What is it? Here, some other way of explanation I'm taking. Sir, everyone knows this. Secant square phi minus tan square phi is equal to 1. From this, secant square phi is equal to 1 plus tan square phi. From this, what we can write? Cos phi, I want to write. Reverse it, root. So 1 by root of 1 plus tan square phi. Clear? Right. Now, therefore, cos phi is equal to 1 by root of 1 plus. So what is tan phi? This entire value I'm substituting that. Root 3 W1 minus W2, right? By W1 plus W2. This portion square. this formula was there in those options. Both are correct only. This is also obtained from this formula only. And this is also obtained from the same formula. That's why, yes, this is a total discussion regarding two-watt meter method concept and corresponding mathematical discussions and all. That too, two-watt meter method is not only for active power measurement. No, reactive power we can calculate, apparent power we can calculate, power factor angle we can determine, power factor also we can determine. That's what the total discussion regarding the biggest topic, two-watt meter method. Clear, guys? Right. Definitely, I did not say any day. I told every day, come prepared, come prepared. But today I'm specifically mentioning that today's class must and should be prepared. Otherwise, total power measurement you need to forget. Because one time you are listening, concept will be clear but not sufficient. You need to practice on your own everything. The topic itself is like that. In-depth concepts are there, in-depth numericals are there, in-depth figures are also there in this. So that's why be clear with the terminology. Yes, you're saying that clear. Okay, very good, happy. But you need to practice at any cost. At any cost, you have to practice. Now, I'm taking few simple questions. Sir, W1 is to W2, right, is equal to W1 is to W2 is equal to, right? What is that? 1 1 is to 2, I'm saying 1 is to 2, right? Find the power factor value. What is that? W1 is to W2 equal to 1 is to 2 means W1 by W2 equal to 1 by 2 means W2 is equal to 2W1. Kindly bring the formula. Cos phi is equal to cos of, what is it? Tan inverse root 3 W1 minus W2 by W1 plus W2. Substitute all the values and tell me the power factor. In the question, lagging or leading are not given, no need to worry. Simply magnitude. Dinesh, W1 minus W2 is not the three-phase reactive power. W1 minus W2 is just reactive. If you multiply with root 3 VL IL cos phi, that is what? Totally which one here? Three-phase reactive. Ashish Kumar, what is apparent power theoretically? That's what the thing actually. Combination of active and reactive power is called as apparent power. One thing. One more thing is whatever the power given to the industry by the three-phase system. That's why I'm not taking your house as a load. Three-phase load is there. No, the power given by the electricity board people to your company, your industry is apparent power. What you will consume, active power you will consume. What will be stored, what will be wasted in the devices, reactive power. This is what the simple idea, right? What we utilized, active power. What is wasted in the system, stored means reactive. Combination is called as apparent. That's why apparent power only will be supplied by the electrical, what is it, department. Yes, give the correct answer. Very good. What is it? 0.866. Okay, right. Next one. W1 is to W2 is equal to 5 is to 3. Direct answer. Give me cos phi is equal to. Try this. Right. Ashish, correct. Okay. Yes, very good. 0.917. Okay, right. I'm giving two questions as a practice purpose. After the break, I'll continue. But by that time, you can take the break and come back and do this. W1 is 2000 watts. W2 is 500 watts. Power factor is dash. W1 is 2000 watts. W2 is minus 500 watts. Power factor is dash. Take these two questions, try to solve, but take the break and come back. I'm keeping this page. Take the break and come back. Let's come back, everyone. What's the answer? Right. Here, this answer will be 0.693. This answer will be 0.327. These are the answers for this. Right? That formula substitution only. Nothing new in that. Yes, but many people give the correct answer. Right. Sir, now I'm taking the continuation topic. Right. Sir, very, very, very important here. What I'm taking now, first I'm taking W1 is equal to W2. Sir, if W1 is equal to W2, what is the power factor value? W1, W2 equal 0. 0 into root 3, 0. Tan inverse 0, 0. Cos 0, 1. So therefore, what is it? Cos 5 is equal to 1. Okay, next. Sir, W2 is equal to 0 or W1, not both, either W1 or W2 is 0. Then what is that? So W2 0, 0, W1, W1 cancel. Tan inverse root 3, 60, cos 60, 0.5. So therefore, power factor will be 0.5 under this condition. Power factor is 0.5. Right? Next. Sir, if W1 is equal to minus W2, if W1 is equal to minus W2, right? W1 is equal to minus W2. What is that? Considered here. W1 is equal to minus W2, 0, something by 0, infinite. Tan inverse infinite, 90, cos 90, 0. So power factor is 0. Power factor is 0. Right? And with the earlier examples, concentrate here. What I'm writing, in this case, I'm writing second one. W1 is positive. W2 is also positive. W1 is not equal to W2 if this condition happens. Next, W1 is positive. W2 is negative, but W1 is not equal to minus W2. Then what will the power factor? Already I gave the question. Sir, W1 positive. W2 positive, but both are not equal. What is the value? 0.693. You take any value, you will get this. What is it? 0.693, 0.75, 0.86, etc. And in this question, W1, W2, both are positive. Both are same direction, not equal, 0.866. In this case, 5:3, both are positive, 0.917. Both are positive but not equal, 0.693. What does it mean? With the numerical question only, this is not the, what is it? Direct concept, experimental approach only. That's why questions I gave you first. Both are positive. One is 2000, one is 500, or one is 5 and one is 3 ratio. Like that will be there. Then the power factor will be, 0.5 less than cos phi less than 1. Check it. You take any question here, 1000, 2000, 500, 600, 700, 800. Any number you take, both positive but not equal. Definitely you will get the 0.5 power factor between 0.5 and 1 only. Proof also I gave you. This one, example. Okay. Sir, with the proof only, kindly don't get confused, or how are you writing means with the experimental analysis. But as we can't do experiment here, I give the numerical questions for clarity purpose. That's it. Okay. Now, sir, one is positive, one is negative, one is positive and one is negative. Then what will be the power factor? 0.327. You take anything, 200 minus 500, 1000 minus 600, 700 minus 600. Anything you take, one is positive, but both are not equal. Therefore, the power factor will be 0 less than cos phi less than 0.5. Right? Okay. Sir, this is the total discussion here. You take any paper in all over India, you take any paper, electrical or instrumentation, combination, examination, anything, if measurement subject is there, right? If you see 100 papers, at least 90 papers, this question will be there. If measurement and power measurement topic is in there, definitely 100 out of 100 papers, 90 papers, this question from this topic will be there. That is very, very, very popular topic. Clear? I'm coming again before going to the next topic. Concentrate. First point, third point, and fifth point, I have written by the formula directly by substituting. If W1 is equal to W2, power factor of the load is 1. If W2 is 0, power factor of the formula 0.5. Both are equal and opposite, power factor is 0. Like that you have taken. But this, I'm repeatedly saying, don't get confused. You missed nothing. Those who those who joined late after the break, no need to worry. You miss nothing. This and this with the earlier numerical questions only I have explained. Clear? Okay. Now actually I'm expecting one doubt here. Concentrate. Sir, in our wattmeter, 0 to full scale value only that is wattmeter. But sir, negative reading, how we are getting? That's not a very important point. Sir, how do we get negative reading? How do we get negative reading? Means concentrate. Very, very, very important. IN people, this is completely beyond your level actually, but I need to explain as the measurement subject is being taken. Be clear. But electrical people, it is just a revision from the machine subject. What is it? Here, induction motor is there. Induction motor. IN people, don't worry. What is induction motor? Everything I will take in your machine subject. Don't worry. IM, induction motor is there. This is generally 3-phase induction motor. In this induction motor, we are having no load test. Why and all I'm not giving? Simply no load test, right? 3-phase supply, automatically which method here? 2 watt meter, W1 and W2. These are 2 watt because 2 watt meter method is universal method. That's why in all the 3-phase measurements, 2 watt meter method only. 2 watt meter method only. Okay, before going to that, this is what the main problem. Listen first, I'm saying. Listen first, I'm saying. Govindu, I told you either W2 or W1. I told you when I was explaining, but I'm writing only one. Either W1 0 or W2 0. Cos phi is 0.5 only. Cos phi is 0.5 only. Either W2 or W3. So W1, not both at a time. Either of this or this. That's not the point. Right? Okay, come back to this. Sir, under no load test, concentrate. Suppose this is the induction motor, right? This is the line, 1 watt meter here, 1 wattmeter here you are connected, right? This is open circuited. Open circuit means no load. Everyone concentrate here. Under no load condition means the no load condition itself is the power factor will be less than 0.5. That's why I told you in the yesterday's class also, open circuit test of transformer, LPF, low power factor condition. I told you, no, yes, no load condition of the induction motor or no load condition of the transformer or generally no load condition is treated as what is it? Low power factor. That is the nature of the load. Why? You will study in your missions, electrical people, IN people, no need to worry for that. Okay, that is what? Low power factor, 0.5. Okay, sir, low power factor is there. What is it? Sir, low power factor is there. Negative reading is coming. If no power factor, the load is very low. One of the wattmeter reads negative. Sir, how the negative reading? That's what I'm explaining. How the negative reading will be there into picture. How the negative reading is there. That's what the picture. Kindly concentrate. I would like to say one more thing. If you joined late, don't ask the doubts from the missed topic. You need to watch the recorded videos and go through that. Otherwise, what I think is you attended, but you are missing the topic. That's what the main. That's why I'm requesting everyone, those who are joining late, if you miss any topic, don't ask the doubt because you miss the topic. No, after the class, recorded video is it. Watch it. Otherwise, I'm feeling like I explained, but still people are doubting means I'm getting doubt on myself. Generally, faculty gets that. That's why don't do that. Okay, right. Now, the question here is, sir, under no load condition of the any mission. So therefore, under no load condition, due to the no load nature, I don't know how many of electrical people remember this experiment. I don't know, but I'm taking this. It is just revising of your topic. So no load. Under no load condition, 1 wattmeter reads value like this. This is the scale, full scale value. Yes, it is going to this one, some 1000 watt, for example. Okay, W1 1000 watts. W1, W2, no problem here, no problem. 1000 watt. But if you observe keenly, right, in this wattmeter, the pointer was at 0 to some full scale value according to the capacity. But after giving this entire supply, in this, the pointer tries to move below 0. Actually, strictly speaking, if you take the instrument below 0 and above full scale, some tolerance gap, physical gap will be there. Physical gap, only small gap will be there, right? That's why the pointer has to move in right side, but pointer is trying to move below 0. We can understand exactly 0 to slightly below 0, but space is not there. It cannot move further. That's why slightly below. What we can understand? Okay, the pointer of this wattmeter, the two pointer of 1 wattmeter only. Pointer of 1 wattmeter is trying to move below 0. Why? That is what I told you. That is no load nature itself is that due to the no load in one of the wattmeters, reverse torque is produced. That is called as effect of low power factor. That is called as effect of low power factor. Sir, if the wattmeter pointer is moving below 0, can we take any reading here? No. But as the student in the laboratory, we do like this actually. We let them give the connection. Okay, we do that. After giving the connection, we check the connection. Everything is good. And let us start the experiment. No load condition. Sir, 1 wattmeter, 1000. Other wattmeter not showing. People are noting down 1 W1000, W2 0, and they are proceeding. Not 0 here. It is slightly trying to move below 0. Therefore, by explaining this entire thing, okay, Vinita, yes, very good. If you observe this, very good. In the laboratory, we explain that, okay, the pointer is trying to move below 0. Why means the effect of, what is it? Low power, no load condition, under low power factor condition, less than 0.5. The reverse torque will be there. We explain in the class and we prove in the laboratory, in the machines lab generally. After that, okay, it is moving below 0. But as the mathematical concept is being taken, can we take the below 0 value? No, no scale is nothing. That's why, what is it? Okay, reverse torque is there. I should make that as a forward torque. How do you make it? Simply here, after showing this entire thing, we make the students to switch off the supply. Okay, supply will be switched off. Whatever the wattmeter pointer tries to move below zero, be clear, in that wattmeter, undoubtedly, which connection? Directly, which one here? MC short only we use, MC short connection only. Sir, this is M, this is L, nothing is mentioned, C and V. Sir, in this, due to the nature of the load, kindly don't ask why. That is the effect of no load condition. You study more in the machine subject. But my topic I'm taking, due to the effect of no load condition, due to the effect of low power factor, one of the wattmeter pointer tries to move below zero. Therefore, we need to make the movement of the pointer above the zero. How? Reverse the torque. How do you reverse the torque? Means change the flux direction. How do you change the flux direction? Means simply reverse the coils connection, but not both. Suppose if you're reversing L here, M here, V here. See, suppose if you're reversing both, do you get forward torque or still reverse torque here? Still reverse torque only. That's why only one of the coils connection must be reversed. One of the coils connection must be reversed. Yes or no? Suppose I'm taking this is negative, this is positive. For example, so negative into positive, negative torque is like this. Sir, if I want to make it forward, I should reverse both or only one? I should reverse only one. If I reverse both, again plus into minus, same thing will be there. That is the reason why what we can say, reversing only one of the coils connection automatically. Sir, M, L here, M here we do. Either potential coil or current coil, anything you can take. Generally, people will change V and C also, no problem. L and M also you can change. Sir, what is it becoming here? L is coming over here. M is coming over, means automatically, what is it? Low power factor. Which connection we are using here? LC connection. That only I told you. Under low power factor condition, LC method we use. But you may be asking, sir, other wattmeter MC, no? Other wattmeter MC only. But due to this, one wattmeter is connected as a LC. Suppose we are going for single phase power measurement, LC connection directly. But this is three phase. No, one will be working properly due to the effect of no load, and due to the effect of no load, one wattmeter is working reversely. That's why whatever the wattmeter is trying to show reverse value, you have to make it positive by reversing coils connection. That's why what is the meaning of negative reading? Means the instrument will not show the negative reading. Okay, be clear. Sir, I have reversed the coil. Okay, after reversing this, the wattmeter is showing 300 watts, for example. We should take in the experiment analysis 300 or minus 300, means we should take this as minus 300. We should take this as minus 300. Right. Vaspalli Hema. Yes, sir. We did same like that, sir. By very good, very good, very good. Right. Clear? So therefore, what's the point here? After reversing, if it is showing 300, you should take this as minus 300. Okay. So therefore, I'm writing now the negative reading. The negative reading of the wattmeter indicates the value shown by the wattmeter after reversing one of the coils connections. But be clear here, I'm not mentioning under no load, under low. No, already it is there. When do you get negative? Below 0.3. Below 0.3 means low only. That is what the major conclusion is. Okay, right? If you use a digital, okay, that is no problem. But if those who use the analog, they can understand this. Digital, no need to worry. Okay, right, sir. One more thing, only electrical people, I'm giving one small point here. Sir, W1000, W2, how much? 300. But most of the people will take like this. Sir, W total equal to W1 plus W2, 1000 plus 300. They proceed like this. This is, what is that? No load power. After that, you will be conducting block rotor resultant or something. By utilizing this, you will draw the circle diagram. Okay, I can say openly, confidently, I can say 80% of the students draw the circle diagram by kind of, don't mind I'm saying this, draw 80% of the students have drawn the circle diagram by only freehand. They have drawn. After that they joined, because faculty cannot measure all the 60 members correct or not. Many people did like this because electrical people itself is getting the fever related to circle diagram. Circle diagram, not, no, I cannot do it in that way. Because why the circle diagram is tough, why the circle diagram tough, starting step only you're doing the mistake. Starting step you're doing mistake means wherever you're using this one, step by step, accumulated mistakes will be there. Finally circle diagram will be coming like this, etc. Simply you do like this, you erase this one. Listen, why means, I mean, different cases. That's why here, what is it? It is not the positive. It is after reversing means minus. Means it is minus means 700. Instead of 700, if you take 1300 as the no load power loss, do you get wrong? Definitely wrong results only. That is the point. But those who are perfect with the circle diagram, yes, very good. They know they know very in detail about the induction motor. But fortunately, they're lucky people. In the gate machines, electrical people, what is it? Circle diagram is not there. Happy. But topic is then I'm giving this hint. That's why in the laboratory, each and every step you have to follow properly. Yesterday I told you one experiment. Today I'm giving one experiment. Clear? So this is the total discussion regarding the entire chapter of power measurement, DC power measurement, single phase AC power measurement in yesterday's class. Today only three phase power measurement. Okay. Then those who are taking negative, yes, okay. But I told you 80% of the people means you are in the 20%. Right. Very yeah, that's what. After getting the wrong, you are correcting, okay. But by that correction only, feeling like circle diagram, tough, leave it. Tough, leave it. That's what the main tendency of electrical engineer. Right. So this is what the complete discussion regarding induction. What is it? Sorry, not induction. That is three-phase power measurement related to the entire topic. Clear? If it is clear, let us go to the questions. Let us go to the questions. Jayasri, thank you so much. Rohit, those methods are not there in the gate nowadays, no need to worry. Those methods are not there, no need to worry. Clear, guys? Right. Let us take many questions. Now, total all varieties of different possible connections of questions we are going to take. Right. Thank you, Vinita. Kindly be ready with the calculator and all, etc. Right. So, is there a reactive power meter? Actually, good question. Nowadays, the digital meters, three-phase meters are there, no? Right? If you see that, all will be there: apparent power, active power, reactive power, power factor. Everything will be indicated in the energy meter itself. But I told you, our what is that? Syllabus is long back, old day syllabus. But concept is there only. If I take the digital, you cannot understand. Program is there over. But that's why they are keeping few topics, olden day topics only, to get the more and more what is the concept in the corresponding thing. Yes. Pramod, that is the main thing. Yes. See, weightage is very less, but this subject is not to be studied only for weightage. All I told you, very good. phase. See, one student is asking that Jitendra Latwal, why don't we connect one phase to the ground directly? Phase to the ground. Electrical engineer should not say this at all. Power system. See, one student doubt is no, I'm giving this statement to other people also, so that if you have the doubt, you should clarify. Sir, in the 1 wattmeter method, what is the necessity of neutral? Why can't we ground the phase directly? Come on, yeah, come on. Do you ground the phase terminal? Come on, no way, no way. The meaning itself is no way. The phase ground phase. Any method is there in your entire BTech or entire electrical engineering? No, neutral ground will be there, but phase we cannot ground here. Come on, come on. Dinesh, correct, actually, correct. Yeah, Amrit Sagar, correct. Means fault condition means the phase wire is broken and falling on the ground. That is LG fault. Under LG fault, do you connect the wattmeter and do you measure the power? Definitely no. Definitely no. Fault connection means we try to remove the fault condition, etc. That's what. Okay, no problem. I'm not saying that don't ask these doubts. No, you can ask, but I'm giving the clarity. Right. Ankur, that is the next topic. That is the next topic. I'll come to that. Right. Wattmeter, if you are connecting the wattmeter to the ground is also neutral. So therefore, that is implying neutral wire only. You're missing small point. Anywhere ground, zero potential, definitely that is acting as neutral notation. That's it. Right. Okay. Now let us take the questions. Kindly solve all these questions one by one. One by will be taking as many as possible questions. I'm taking now. The moment we are solving one by one question, different connections of circuits are also coming into picture. Then more clarity will be there. Thank you, Sunil. Thank you. Yeah, Hema Vardhan Reddy. Yeah, nowadays so many features are coming, switching action, etc., etc. Ashwin Prasad, I'll explain your point just after this question. I'll explain. Sir, VL is equal to 400 volt. IL is equal to 10 ampere. Cos phi is equal to 0.866 lag. Nothing but 5 is equal to 30. What is asking? The reading of the 2 wattmeters. Which one? Lagging load. Sir, under lagging load, what was the wattmeter reading? W1 is equal to. W1 is equal to. What is that? VL IL cos 30 minus 5. In our lagging case, we are taking up VL 400 into 10 into cos 30 minus 30. What is the value? 2000 watts. Sorry, 4000 watts. And W2 400 into 10 into cos 30 plus 30. Cos 60 1 by 2 means 2000 watts. Direct question. But now I'm going to take many number of questions, but I need your patience. I'll be taking varieties of questions equally important for both IN as well as electrical people. Yeah. So please solve that 1997 problem. Which one? 1997. So kindly concentrate. 1997. After that, in 2004, syllabus is revised. 2019, syllabus is revised. 2013, syllabus is revised. 2020, what is it? 2021 also, syllabus is revised. That's why long back questions, long back concepts, so many things are not there in nowadays class. Nowadays, syllabus, don't worry. You try it. If you're getting okay, if any topic is not covered, etc., that is old syllabus, not the present syllabus. Make it right. Okay, now let me take one more question. That is one by one more question I'm taking. That conceptual question. Yeah, 97 models. I'm going to solve, no need to worry. Four plus, yeah, I'll solve that question, no need to worry. Right, concentrate guys. I'll be doing very simple question here, very simple question. Sir, here voltage E1 sin omega t, E3 sin 3 omega t means first order, third order frequencies are there. Current, first order, third order and fifth order frequencies are there. Okay, sir, what is the wattmeter reading? First of all, what is the wattmeter reading? Concentrate. Wattmeter equal to Vrms I RMS into cos phi. So what is Vrms? Vm by root 2 Im by root 2 cos phi. So therefore finally 1 by 2 into Vm Im cos phi. This is what the general formula. Okay, now I am starting the question. Sir, 1 by 2. Sir, what is Vm? E1 is the maximum. So E1. What is the Im of first order? I1. Angle between this omega t minus phi 1. What is it? I1 cos phi 1 plus. Third order also there. Third order maximum voltage E3. Current I3. Cos of angle between 3 omega t minus phi 3. Cos phi 3 plus. Sir, fifth order voltage is not there. Fifth order voltage is not there. Current is there. So simply 0 into something 0. This is what the direct formula based only the question is given. But concentrate. First order voltage, first order current, first order frequency related phase. You have to combine like this. And you have to combine like this. Don't combine E1, I3, I1, E3. No, E1, I1, E3, I3, E5, I5, so on. But E5 is not given. No problem. This is what the answer. Clear? Right. Right. Very good. Next one. Different types of question means wattmeter connected in different possible connections. Right. I will do this. No one should try. No one should try. Kindly concentrate on the concept. I will do it. After that, these type of question you can do it. The circuit shown in the given figure. The wattmeter reading. This is the wattmeter. Current potential coil. Yes, this wattmeter reading is dash. Okay. So always wattmeter reading means potential coil voltage, current coil current, cos of angle between these two. General formula. Okay, sir. Here, potential coil is, concentrate guys. Potential coil is this, connected across how much voltage here and here. What is it? 200 volt. Potential coil is 200 volt. So therefore, there is no problem for this one. What is that? 200 into current coil current into cos of this one. So what we have to concentrate? Current coil current. Everyone see the figure only. Don't get distracted. You'll be missing the topic. Concentrate. Sir, this is the current coil current. IC. We don't know. Sir, same current is coming like this. But what is a CT? Next chapter will be there. Current transformer. Current transformer. Even IN people also knows that transformer means, I hope, primary will be there, secondary. That is enough. After that, instrument transformers clearly elaborated. I'll explain later. Okay, CT, current transformer. This is I secondary. And this is I primary to secondary, and this current is load current IL. Everyone keenly observe here. Sir, current coil current is nothing but secondary current of the transformer. Primary current of the transformer CT is nothing but IL. Yes or no? Primary current is nothing but IL. Now check it here. Sir, 200 volt is directly applied across the load. Okay, but here, sir, CT primary is coming in series. No, means CT primary voltage drop is neglected. Why? I'll take it in the CT chapter. Don't worry. So therefore, here 200 is there. Same 200 will be coming over here. This voltage drop will be very, very, very negligible. We neglected. That is what the practical theory, practical as well as theory. I'll explain the instrument transformer. No need to worry. That's why the first step is, sir, IL is equal to 200 volt by ZL 4 plus J3. 4 plus J3. Right? Okay. Sir, 200 by 4 plus J3 convert into polar form. Phi at an angle 36.86. Okay. Now it can be written as 40 at an angle minus 36.86. What is this? What is this? IL. Sir, in the diagram, IL is equal to I primary. So I primary. Okay, right, sir. What is the ratio he has given? If primary current is 50, secondary current will be 5. But what is primary current in our operation? 40. Simply, second step. 50 ampere gives 5 ampere secondary. 40 ampere gives dash. Why? This is the rated value. This is the rated value. What is it? 50 amperes primary gives 5 amperes secondary. That is a rated value. That's why 50 is the 10:1 ratio. So 40. Therefore, what we can write now? I secondary 40 by 50 means 10:1 ratio. No, 4 amperes. Sir, what is I secondary? I secondary is the but IC. Therefore, IC. Now go to the first topic. Therefore, W, first topic, this one. Potential coil voltage, 200 already there. Current coil current, IC is here, IC, no problem. Current coil current, right? What is it? 4 into cos of angle between these two is how much here? 36.86. So simply 36.86. You will be getting 640 watts. Like this, so many different types of wattmeter circuit connections I'm going to solve so that you can understand wattmeter, current coil, potential coil. Wherever we want, we can connect it. According to that, we need to analyze it. That's what the point. Answer already, many people give that 640. Very good. What is the answer? Yes. Right? Like this, so many questions I'll be taking. Right. Next one. Is this values clear? One second. Repeating same thing, some other figure. I'm requesting everyone, don't try. If nothing is given, no need to worry about the dot convention. If dot convention is given, take it. Otherwise, normal flow only you have to take. And Urukunda Satish, people are asking very good question. Sir, actually transformer means primary to secondary 180 degree shift is there. No, you substitute here 180 plus 30, 180 plus 36.86, 180 plus theta, cos theta, same answer, no problem. Cos 36.86 or cos 216.86, no problem. Minus or plus will be there, no worries. We want only magnitude, don't worry. That's what I told you. Manikanta, just now I told you, what is that? Even though you take 180, answer will be same, so no need to worry. Okay, right. Kindly don't try here. I will do this in this chapter, especially I will do concentrate only when I'm explaining, concentrate, because different possible connections, no, right? It will be little bit difficult, that's why concentrate. Sir, here, what meter is connected like that? How? Current coil, this is the current coil, this is the potential coil. He has mentioned clearly, a single phase load is connected. A single phase load is connected between R and Y terminals. Check it. This is the load connected between R and Y. It is not connected between R and N. It is connected between R and Y. That is his wish. We should not question how he has connected. Based on this connection, we need to analyze. Very, very, very important question. Very technical question. Logical question also. Major people will do the small mistake. Kindly concentrate. Terminals of 415 volt, symmetrical 3-phase 4-wire with phase sequence RYB. How much voltage is there here? He has given 415 volt R to Y. Sir, VRY means line voltage or phase voltage, R to Y line. When do we say phase? R to N, Y to N, B to N. Those are phase voltages. But this is line. How much? 415 volt. Okay. From this phase, what is phase? Already proved, no? VL by root 3. So 415 by root 3. Keep it as it is. Okay. Sir, what meter is connected in the system as shown figure? Okay. Current coil here, potential coil is between other two phases here. We can, sir, how do we connect? Means I told you already, M, L, C, V. Terminals are brought outside, left free. Wherever you want to connect, you can connect them, no problem. Yes, here also, M, L, C, V. He has connected in the different fashion according to his requirement. Okay, right. The power factor of the load is 0.8. This is 0.8 lagging the watt meter reading. He is asking watt meter reading. Very, very, very important. No one should try. I'm requesting. No one should try. Right? Kindly don't try. If you try, definitely you will be missing the topic. 100% guarantee I'm giving. Concentrate. Sir, let me write. First, always you have to write watt meter reading. Potential coil excitation, current coil excitation, cause of something. Angle between these two. So what is potential coil? Check it. Potential coil is connected between B and N. So VBN. Okay. Current coil is connected between R and Y terminal. Is that no? Which is load only, but RY. IRY. Cause of angle between these two. Sir, what is VBN? VBN. What is VBN? V phase. So simply 415 by root 3. Okay. Sir, concentrate guys. Concentrate. Follow this arrow. Sir, I through this entire path, IRY. What is IRY? VRY by opposition. Current coil impedance is not given, which is given Z. So therefore, IR means current through the current coil is equal to 415 by 100 ohms is given. So therefore, into 415 by 100. But very major point is into cos of what people are taking. No, so 0.8 is there, therefore 36.86, 36. No way. So why? I'll tell you. Means this question is majorly with respect to which one here? Angle only. How do you get angle? Very important. Concentrate. Phasor diagram is compulsory. Sir, this is VRN. VRN. Okay. This is VYN. This is VBN. Okay. Whether he mentioned or not mentioned, simply have to take balanced only. He has not mentioned balanced. If it is unbalanced, he will mention. So no need to worry. Okay. Sir, RY we have taken. Sir, here. What you require? VBN already there. I'm writing here. Angle between VBN and IRY. VBN and IRY. That is what we require. Correct? Right, sir. IRY. Right? Okay. Now, sir, VBN IRY. What people doing the mistake here is, what mistake the people are doing is, concentrate. They are drawing like this. IRY. Sir, this is 36.86. What we require? Sir, VBN and IRY means VBN to IRY 120 plus 36.86. Sometimes they're substituting 156 also. It is also wrong. Sir, why? Why it is wrong? Concentrate. Sir, IRY is a line current. VRN is the phase current. Line current lags the phase current. No, phase voltage. No. Line current lags the line voltage. Phase current lags the phase voltage. That's the basic point. So that's why IRY should not be in 36 degrees with respect to VRN. No. That's why what you have to do, we need to find out IRY position, means we need to find out VRY first. That's why I'm reversing this vector. Concentrate here. I'm reversing this vector. What is that? This is minus VYN. And if I add this one, this vector combination, I'm drawing with light color like this. So finally, this vector is which vector, guys? VRY vector. Okay, now tell me, sir, what is this value? This is 30. Why? 180. This is 180. This is 120. This is 60. This is 30 only. Same concept. So therefore, concentrate. After drawing VRY, now you can say that, sir, IRY, concentrate here. Current through RY. Current through RY lags by VRY. Where is the question of VRN? Check it. People are drawing now. VRN. Actually, R to N. There is no direct connection in the question. That's why VRN will not come. So therefore, what is it here? I'm writing. Note here. IRY lags VRY by 36.86 degrees. This is the key role in this question. What is it? I'm coming again. So current through R and Y. Current through RY lags by VRY. There is a question of VRN. R to N direct connection. He has not shown in this. RN will not come. Okay, VRY. Now, IRY lags the VRY means, sir, IRY will be coming here. No doubt. IRY. But this is not 36.86 because IRY lags the VRY by 36. So therefore, this angle is how much here? 36.86. So automatically, sir, what will be this angle? This angle will be 6.86. Now I'm writing, therefore, W is equal to 415 by root 3 into 415 by 100 into cos of, sir, angle between VBN and IRY. Why here? Potential coil is BN, current coil is RY. So therefore, VBN from here to here. From here to here. This one. What is it? Here to here, 120 plus 6.86. Therefore, 126.86 is the correct answer. Not 36, not 156. Answer is 126. That's why whatever the question he has given, follow the wattmeter potential coil, wattmeter current coil connection, angle between those two. If you follow this step by step, thing will be done. Now, if you simplify this, you'll be getting minus 596.46 watts. Yes, Kumar got it. Correct answer. Other than this, you take anything, 36 you take or 150, definitely wrong only. Definitely wrong. Clear? Right. I'm repeating. Total problem I'm repeating. Like there's so many things. Not only this, 2, 3, 4 questions are there in the lengthy conceptually questions. Concentrate here. I already explained. No? Those who are writing, you are written now. Now everyone stop writing. Anyway, notes we are providing. No need to worry. Everyone stop writing. I'll explain again. That's what. The main concept people mistake is that angle there. Yeah, that's what. Angle only the main problem here. Otherwise, these two are very simple. Now I'm coming again. Concentrate. First point, sir. Current. I'm giving this mark here. Concentrate. Current through R Y. Nothing but I R Y. Lakhs V R Y. By how much load? 36.86. First write this. Okay. Come back, sir. Here. V line 415. V phase 415 by root 3. After that, sir, wattmeter. Potential coil is between B and N, VBN. Okay. Current coil is RY, IRY. Cause of angle between these two. So what is IRY? VRY by opposition in this path. How much? This opposition neglected. 100 is there. 415 by 100. Up to this, no problem. But phasor diagram. Phasor diagram completely depends on this statement. Sir, VRN, VYN, VBN we have taken. Okay, after that. Sir, VYN I have reversed it. Minus VYN. VRN minus VYN combination is RY. VRY. Combination is VRY. Okay, sir, VRY and this phase obviously 30 degrees. Why? Parallelogram law 30. After that, sir, IRY lakhs VRY. IRY lakhs VRY by 36. Sir, already 30 is there. 6. So totally 36.86. IRY. After that, simply, sir, angle between VBN and IRY. Sir, this is VBN. This is IRY. Coming again, this is VBN. This is IRY. This value is dash. Sir, 120 plus 6, 126.86. Clear? I have revised. Kindly concentrate. Every time saying here, this topic definitely every word by word, sentence by sentence, and what is it? Formula by formula. You need to write separately while you practice rough notes and practice. Then only thing will be clear. Right. So why you have taken VRY equal to VBN? Who told VRY equal to VBN? Where I have taken VRY equal to VBN? Where I have taken? I have not taken. This is formula. After that, potential coil VBN. I have not taken VRY equal to VBN. Never, I have not taken anywhere. I have not written also VRY equal to VBN. No. Connection VRY. That is what? Voltage. But potential coil is BN. You are missing. Potential coil is between B and N. Thanks. Okay. Right. Next. Like this, so many questions there. Right. Again, few people are asking that, sir, IRY lags VRY. See the figure here. If you see the figure clear, sir, IR, okay, it might not be visible. This is R, this is Y, this is B, this is N, right? Kindly concentrate here. Because if you understand, other questions will be very simple. Current through the current coil, R to Y connection is there. IRY, IRY. How much voltage? VRY. IRY lags VRY by how much? Here value is given here. 0.8 PF. 0.8 PF means 36.86 angle. So, Jana, clear? In the circuit only. In the circuit it is there. Right? Now, next one. Next question. Right? So, it is also same conceptual question. Okay, right, sir. The figure shows three-phase delta connected supplied from a 400 volt, 50 hits, three-phase band source. This is the balanced source. This is balanced source. R, Y by is given, but to confuse you, this is given as A, but R later I can take it as R, no problem. Sir, B, I'm taking this as B. Sir, Y, I'm taking this as Y, no problem. To confuse you, A, B, C here, R, Y, B. To avoid the confusion, R, Y, B, I'm taking. But how he has connected, no? Between B and Y, potential coil is connected. Between R and B, current coil is connected. He is asking, what is the wattmeter reading? What is the wattmeter reading he is asking? Okay, now, concentrate here. Right, up to this only I have taken pressure coil and current coil of the wattmeter connected in the load shown, etc., etc. Okay, but kindly don't concentrate on this one. I will come to this later. Okay, the wattmeter reading will be dash. The wattmeter reading will be dash. Okay, now I'll come to that. So kindly in this also confusion will be there, but concentrate. So in this question, phase sequence is not given, right? So we are assuming balanced source he mentioned, and I am assuming like phase sequence is R, Y, B. I'm taking R, Y, B. Okay, sir. Everyone, this is a representation here. Electrical people know about this, but IN people, sir, if I give the box like this and if I give 400 volt, it means R to Y 400, Y to B 400, B to R also 400. That is what the representation with box. So therefore, what is given? RYB sequence? No. VRY I'm taking, VYB I'm taking, VBR I'm taking. You may be asking, sir, why only facing RYB? You take other phase sequence after the class when you're practicing. Take other phase sequence, solve this, you will get the same answer. No need to worry. One of the phase sequences I'm taking. That's why RY, YB, BR. What is the magnitude? 400. 400. 400. Why? Balanced. Balanced means 120 degrees phase also should be there. 0 degrees. After 0, 120 degrees. After 120, again 120 means minus 240. Am I clear? Electrical people, they know about this. This is general representation. But IN people, I'm asking this question. What is it? RYB sequence, I assumed. Why? No reason. You can take RBY, any sequence you can take it. RY, YB, BR I'm taking. What is that? Balanced source. Balanced source means magnitude of same, angle must be 120, 120, 120. People are asking, sir, why minus 120? Means after 0, after means lagging. In that base I'm taking. Otherwise, you can take plus 120, plus 240 also, no problem. But after R, Y should be there. After Y, B should be there. No, in that I'm taking. This is what the introduction. Now I'm taking wattmeter connection. Very, very important here. Every question, wattmeter connection is important. Sir, wattmeter. Where you have connected the potential coil V, I, cos of angle between these two. Sir, potential coil is connected between Y and B. Our sequence is YB, no? So I'm writing YB, VYB. Okay. Sir, current coil where you have connected, current coil B and R, IBR, clear? IBR, cos of angle between VYB and IBR. Sir, magnitude is very simple. Sir, VYB, what is the VYB magnitude? 400 into. Everyone, see the figure keenly. Sir, what is current through the structure? IBR, check it here. Current through this one means everyone keenly observe my movement, concentrate. R, right? B here means, sir, across these 2 points, how much voltage is there? This and this means VB to R. VB to R. What is the magnitude? 400 only. Yes or no? So therefore, across B and R, 400 is there. What is the opposition in this? Z, 100 ohm is there. Current coil impedance neglected. So therefore, automatically what we can write here? Sir, voltage is 400 by impedance is 100. Voltage is 400 by impedance is 100. But main headache is always with respect to cos of VYB and IBR only. Angle only. Magnitude simple, very, very simple. That's why be clear. Sir, VYB, potential coil. What is that? VYB. So therefore, this is V potential coil. Okay. Now I'm writing, sir, current through the current coil is VBR. VBR. Okay. VBR by this. So therefore, current to the current coil VBR by 100 ohm. Sir, what is VBR? This one. 400 at an angle minus 240 by 100. Check it here. Magnitude 400 by 100. Already we got it. But in this, angle also into picture. 4 at an angle minus 240. This is current coil value. Magnitude directly, but angle is also coming if you take angle here. Now I'm writing, therefore, V potential coil is VYB. What is VYB? This one. 400 at an angle minus 120. Current through the current coil is 400 at an angle minus 240. Now, wattmeter equal to potential coil magnitude 400. Same thing, we got it 400. Current coil magnitude 4. Same thing, 400 by 100, 4 only. Now, VYB and IBR, potential coil voltage, current coil current. What is that angle? Potential coil is at minus 120. Current coil is at minus 240. What is the angle between those two here? 120 degrees. Here people are getting confused. So it is minus 120 now. Come on here. Come on. This is minus 3. This is minus 1. Distance between these two is 2 units or minus 2 units. Distance between these two is 2 or minus 2? 2 only. Yes, that's why cos 120 only. Minus 120 to minus 240. 120 gap. Actually, even you take minus and no problem. Why? Cos of minus, but not correct. If you simplify this, you will be getting minus 800 watts. This is what the answer. But, so minus 800 is not there in the options. But I told you, no, kindly concentrate. Here, with the coil polarities suitably selected to ensure a positive deflection. What does it mean? Even though you are getting minus, what does it mean? The coil polarities are selected such that means reverse. I told you, no, if the wattmeter pointer is trying to show reverse direction, what is it? Reverse the terminal. Like that he has given. With the coil polarities suitably selected to ensure a positive deflection. That's why even though it is minus, we should write, therefore, this is 800 only. But here again, doubts are there. Sir, if this statement is not given, what is the answer? Minus 800, take it for granted. But this is given to confuse you, Why means, see, if you don't read this statement, 90% of the people choose the first option. Why? Sir told that negative reading means Pointer tries to move below 0, but below 0 scale is not there. Therefore, it will show 0. People are thinking like this. Never, never. Why? It has given this statement. So therefore, this one. Clear? In this way, you take any circuit, any connection as you wish. But whatever you have taken, potential coil between these two, write it. Current coil through that, write it over. Right? If the phasor diagram is required, draw like this. Otherwise, in the concept only, all these are given with this word. With this word they have given. All these are given. Yes, we have calculated the phase angle clearly. This is one more model of the question. Clear? Come on, guys. You need to practice again and again and again, compulsory. Right. So how do we, very good. Right, Babu, Nabil Babu, okay, right. So how do you identify VYB or VBY? All I told you know, my assumption is RYB sequence, RYB, RYB, RYB. Sir, RY, YB, BR, I'm assuming. That's what I told you. I give the homework question. Repeat this problem with RBY sequence. That is what the homework I'm going to give. What is it? Repeat the earlier question. Just for more confidence purpose. Repeat the previous question with RBY sequence. RBY sequence. Right. Sir, here 400 volts is maximum RMS. Nothing is mentioned blindly RMS. Only one thing here, that especially electrical people, life itself is this point. Maximum means they will mention. Average means they will mention. Instantaneous means they will mention. Only RMS they will not mention. Directly number will be taken. Okay. Sir, current coil angle, how 240? Concentrate here. Here, current coil, I told you know, current coil, VBR by 100. What is VBR? Check it. VBR is this. VBR by 100. 400 by 100. Here, angle is not there. 0 means angle is not there. Therefore, minus 240 as it is. Right. You try that. You try that. RB by secret, you try that. Right. Shravya. Sir, current direction BR. How to know? See, that is what my sequence. Here you are missing again. RY means my point is R to Y. YB means Y to B. BR means B to R only. That is what the, that's why it is depending on our phase sequence. Don't worry. That what a sequence you're taking, take the direction. Right. Again, this is what the irrelevant questions actually. Sir, in the question, minus 800 will be given, will not be given. Why? If minus 800 is given, you are the lucky person. That's why the main point of the competitive examination is to kill your time. That's it. Minus 800 will not be given. Okay. If minus 800 is also given in this question, the coil polarities are suitably selected to ensure positive. No, still you have to write positive 800 only. Suppose if this is not given, if instead of 0, they are giving minus 800, then you have to choose minus 800. That's what the point. But to confuse you, to kill your time, they will give this type of conflict. Right. And I told you, Jitendra Latwal, other person also asked, BRRB, that depends on what sequence we have taken. What sequence we have taken. Right? If it is unbalanced, Govind, very good. If it is unbalanced, they will give VRY angle, they will give. VYB angle, they will give. VBR angle, they have to give definitely. Definitely they have to give. Right. Correct. Satish, correct. Right. In this question, need not to go by phasor diagram because directly values are given. If direct values are not there, we go to phasor diagram generally. Yeah, definitely. Vinita, very good. Yeah, very, very good. Sir, same answer I'm getting for RBY sequence. Very good. This is the way of preparation. Very good, very good. Right. See, one method I told you, always be clear. One method I told you. Whoever asking like, so that method can we do, this method can we do, after the class, practice my method. After that, you need to practice those your own method. If you are getting correct, method is correct. Getting wrong, talk to me. I will say method is wrong or your anyway mistake is there, etc. In the classroom, one question, 10-15 methods explanation is not possible. Try to understand. Okay. One method I will explain. Other method you try after going home. That is what the way of getting the subject. Right. In the gate, we cannot expect major questions from which topic. No, because last time IIT Bombay, this time some other people, next time some other people. Therefore, repeated models will not be there. That's why you need to focus all the two. You are not pointing out you that Satish, I'm not Satish. I'm not pointing out you, Pramod, right? See, you are writing gate means you have to study everything. That's what the point actually, right? Okay. Now, one more question I'm taking. Right. This is 2017 electrical people question, 2 marks question. Very, 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 very lengthy, but very simple only. Lengthy, but very simple. No problem. I made 3 figures for this because it's very lengthy. I'm requesting everyone not to write anything. If you understand this entire question, total power measurement topic, entire 3-phase power measurement topic, including numericals and phasor diagram, everything will be clear. Everything will be clear. Okay, concentrate. Sir, here, the load shown in the figure, the load is shown here. This is the load. Okay, this is the supply. Okay, 1 second. That figure is not clear, so that I'm showing. It is a little bit more clear. Sir, the load shown in the figure supplied by a 400 volt. What is the voltage here? 400 volt. Line to line. He has mentioned line voltage. 3-phase source, RYB sequence also he mentioned. The load is balanced and inductive. Actually, this question takes more time. Today, it may not be possible to spend the time for doubt session, it seems. But don't worry, it will be clarified later also. But this question, very, 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 very important. Lengthy model, concentrate. The load is balanced and inductive. The load is balanced and inductive. Drawing 3464 volt ampere. 3464 volt ampere. I am requesting everyone keep your pen or notebook keep aside and only see the screen. Varieties of concepts will be coming here. When the switch is S is in N, when the switch is at N, this is the N position. This is the N position. This is Y position. This position is Y position. This position is N position. Okay, right. W1, W2, W3 reads 577.35 watts each. If the switch is moved to position Y, then the reading of the wattmeter in watts will be. This was the question. Don't worry, I'm explaining again. Sir, concentrate with my cursor movement. Concentrate. Sir, switch is at N means like this. Switch is at N in this way. Sir, potential coil of first what? W1, W2, W3. R2, follow this. R to N. If it is R to N, what it is measures here? Phase voltage. Okay. Sir, current coil is IR. So VR to N, IR, phase voltage, phase current, phase power. Sir, VY, potential coil is coming to the N, neutral, because switch is at N, means, what is it? Y to N, IY, phase voltage, phase current, phase power. B also same thing, B to N, VBN, IB, phase voltage, phase current. So automatically, what is that? Single phase power. Okay, that I'm writing now. Step by step, I'm writing here. Switch is at N, switch is at N, W1, W2, W3 is equal to how much here? 577.35 watts each has given. Okay, sir, I already told you, switch is at N, switch is at N. Each watt meter measures which value? Phase power. I'm coming again. R to N, Y to N, B to N. Anyway, line current is phase current only. That's why phase. That's why this is equal to which one here? Phase power. Phase power. So therefore, directly, sir, what is power three phase? Power three phase is equal to 3 times of 577.3. Definitely, single phase power is given into 3 because equal power, no, balanced means. Okay, you are getting 1732 watt. So what is the three phase power formula? This is equal to root 3 VL IL cos phi is equal to 17. Means indirectly three phase power value is given. Indirectly three phase power value is given. Clear? Right. Next one. Sir, what is the apparent power he has given? S is equal to 34. Right. Sir, S is equal to what is that? 3464 volt ampere, means V into I notation. So volt ampere. What is this formula? Already we have proved now. Root 3 VLIL. Root 3 VLIL is given. So root 3 VLIL is directly given. Root 3 VLIL cos phi is we got it. So therefore, sir, cos phi is equal to root 3 VLIL is 3464. Here you can substitute 3464 and you can take this 1732. So therefore I'm writing equation 1, equation 2. From equations 1 and 2, cos phi will be 0.5. It implies phi is equal to 60. Don't worry, I'm not skipping anything. Root 3 VLIL is 3464. Root 3 VLIL cos phi is 1732. Can't you measure? Can't you get cos phi? Yes, 0.5. That is 60 degrees. That is 60 degrees. Okay. Right. The two inductive load now is the solution. Only given data, just I modify it. What is asking now? If the switch is moved to position Y, this switch is moved to position Y, the reading of the watt meters in watts will be. I'm coming again. Concentrate. Switch is at Y. Concentrate, guys. I'm spending much time on this. Concentrate. Switch is at Y. So if the switch is at Y, kindly follow this cursor. V voltage of this one R2, where it is going? Y. So what is the first watt meter voltage? R2 connection is given to Y because which is moved to Y he is asking. So therefore, what is that? W1 is VRY. W1 is VRY. Okay. Next. Sir, W2. What is W2? VY. Why? Why to why you're giving? What is that? Zero voltage. Very good. But I'm writing the formula. W2. V, Y, Y. Sir, W3. W3. What is W3? Check it here. B2, Y. B2, Y. So therefore, VBY. VBY. Okay. After the current coil is same. IR, IY, IB only. Automatic, directly. Therefore, IR, IY, IB. After that, cos of angle between VRY and IR. Cos of angle between VYY and IY. Cos of angle between VBY and IB. VBY and IB. Clear? Sir, undoubtedly this is 0 watts. Why? Sir, Y to Y, directly voltage, Y to Y only. What is that? Almost 0, simply 0. But the moment if you see the options, concentrate. Sir, W2 0, right? W2 0, W2 0. 3 options are there. So definitely we need to proceed. That's why this is given for 2 marks question in the 2017 paper for electrical paper. Clear? So therefore, we need to proceed with the phasor diagram compulsory. Phasor diagram compulsory. Okay, right, sir. What is that? We need to get this angle, then only we can go for it. Sir, what is VRY? VRN minus VYN. What is VBY? VBN minus VYN. So simply, I'm drawing the phasor diagram, but in this small confusion, chance is there. Chance is there, be clear. Sir, this is VRN. This is VYN. This is VBN. Okay, right, sir. What we require? VRY means automatically RN minus YN. Okay, sir, minus YN. This is minus VYN. Minus VYN. Sir, VBY, VBN minus VYN. Yes, already minus V1, we got it. Okay, right. Now, concentrate here. 1 second. Okay, right, sir. IR and IEB also we should write now. Okay, sir, where IR lags by how many? 60 degrees with its own voltage because lagging load. So therefore, IR should lag the voltage by 60 means this is IR. This is IR. This is 60 degrees. Okay. After that, sir, IB should lag the VBN by 60. Sir, IB, where we have to draw? Concentrate, guys. On this vector only, which will be there here. IB will be there. Why? Concentrate. This will be 60. This will be 60. Why? Check it here. Sir, if you are reversing like this 120 will be divided into 60 or not? Obviously. Okay. In the same way, if you're reversing like this, this 120 divided into 60 and 60. That's what the point. Clear? Okay. Right. Now, after here, people are getting confused. So both are on same line. Something is wrong. No, nothing is wrong. Nothing is wrong. This is what? Based on the load nature. Yes, load is 60 degrees lagging. Correct only. After that, sir, VRN minus VYN. VRN minus VYN. Right? What is that? VRY. Okay, we have got it. VRY. Happy. Leave it. Sir, what is that? VBY. VBN minus VYN. VBN, VYN. Right? Right here. What is this? Here. This vector is which vector here? V, B, R vector. After this, we can write everything clearly. What is that? Here only I'm writing for clarity purpose. Sir, W1. What is W1? VRY. What is VRY? VR2Y. How much value? 400. R2Y 400. So 400 into. Sir, what is IR? IR is line current or phase current because it is a neutral point is a star connection only. Therefore, IL equal to I phase. How do you get IL? Means from this formula. Sir, root 3 VL IL equal to 3464. No. Therefore, IL is equal to 3464 by root 3 into VL is 400. You will get the value as 5 amperes. So IL, IR, IY, IB, all are IL only. Therefore, 5 into cos of, sir, VRY and IR. What is that? VRY, VRY and IR. Sir, what is this angle, guys? What is this? 60. This will be 30 definitely. So therefore automatically 90. So this is 90 degrees. So therefore cos 90. So automatically 0 watts. W2 is already 0 watt. Oh no, is or no? So therefore W3 is directly, so how much power? 1732, because total power is 1732. No, yes, this is taking 0, this is taking 0, blindly W3 will be 0, so W3 will be 1732. Clear? Check it here. VRY, VL 400, IR, IL 5 amperes. Cos of angle between these two is, check it here, VRY to this already 60, this is 30 because parallelogram law method. So therefore automatically 90. After getting these two, you can see the options. Sir, W1, W1 0, no. Here W1, W2 0. So automatically fourth option. But people are asking, so how 1732? Simple logic here. Total available load itself is 1732. In this switch is at Y condition, W1 not taking any load, W2 not taking any load, W3 taking the load, total load 1732. But I will prove it. Sir, VBY, what is VBY? VBY is line voltage, 400. Sir, IB means current 5, cos of angle between VBY and IB. Sir, this is, one second, small. This is VBY, right? Okay, now, sir, angle between VBY and IB. Sir, VBY and IB, which angle? This one. How much? 30. This is VBY, this is IB. So cos 30. Okay. 400 into 5, 2000. 2000 into cos 30, 0.866, 1732 will be there. This is the total discussion regarding all types of connections in the single question. Why W2 0? Yes, good. I corrected. Sir, why W2 0? W2 is simple logic. VY to Y terminal. How much voltage will be there? Y to Y only 0. As it is 0, this will be 0 1 directly. Clear? Right. I'm repeating the total question one time so that you can understand more, because this is giving the total concept of total revision of entire thing. Right? One second. W3 should be, yeah. VBY only I have written. VBY only I have corrected. VBY only. By mistake I have written R, but I told VBY, but I have written. Okay. I'm repeating here. First, how much apparent power? 3464. From that, get the value of IL and keep it. When the switch is at N, each wattmeter reads this one. Means switch is at N, check it. Switch is at N. Sir, R to N, Y to N, B to N. So therefore phase. So phase power into 3 total power. Nothing but root 3 VLL cos phi. Root 3 VLIL is this. Root 3 VLIL cos phi is this. So therefore cos phi equal to 0.5, 60 degrees lagging. Okay. Next. Sir, each and every wattmeter, when the switch is at Y means R to Y, Y to Y, B to also Y. So therefore RY, YY, BY. Currents are IR, IY, IB. Angles. This anywhere directly 0. Only the headache with W1 and W3. Okay. Now, so VRY, VRN minus VYN. VRN minus VYN. Combination is VRY. Okay. After that, VBY, VBN minus VYN. VBN minus VYN. VBY. After that, currents. How much? 60 degrees lagging. So here IR lags the VRN by 60. Therefore, this angle become 60 plus 30, 90, and IB lags the VBN by 60. This angle becomes 30. 30. So answer is this. Totally, in this switch is kept at Y position. First and second wattmeters are not taking any load. Not taking any load. Total load is taken care by W3 only. Directly answer, but I proved also. So this is the total discussion regarding various possible questions in this power measurement. Clear? Right? People are asking, so it should be VBY instead of V by B. No, yeah, that is sequence. But where you are connecting the wattmeter here? Y to Y, B to Y only. This is the starting terminal. Connection is different. Sequence is also different. Be clear. R to Y, Y to Y. Here, B, we are connecting B to Y is the written path. So VBY only. This is VBY only. It is not the sequence base. Sequence is RY, YB, BR only. But wattmeter connection is, if that is the case, let me go to my earlier topic once. 2 wattmeter method. One second. Yeah, in this 2 wattmeter. What sequence have taken? RYB. RY, YB, BR should be there. But what meter, how connected here? Y to B have connected, R to B. I have taken in the explanation. What I have taken here? VRB. Sequence is RY, YB. Okay, that is sequence. But what meter? We kept in R phase to B. So RB only. That's why VRB. Don't get confused. Concept is this one. Sequence is for this purpose. But connection is how the wattmeter is connected, that connection only is to be taken. Sir, how it is 60 degrees lagging? How it is 60 degrees lagging? Come on. How it is 60 degrees lagging means in the question itself, concentrate here. Sir, here, root 3 VLIL 3464. Root 3 VLIL cos phi is 1732. Right? You will be getting cos phi as 0.5. 0.5 means 60. Cos 0.5 means 60 degrees. Very good. Ashwin Prasad, that is blind answer. Very nice. Very nice. Very good. Come on. 60 degrees lagging not because of parallelogram, because of the given data. Just like I told you. Because of the given data. What is it? Come on here. I'm repeating. Root 3 VLIL value. Root 3 VLIL 3464. Root 3 VLIL cos phi 1732. In the place of this 3464, cos phi is equal to 1732. Cos phi is equal to 1732 by 3464, therefore 0.5. This is what the point. Right. I'm stopping now. Right. If any doubt is there, kindly let me know. Right. Akshaya, always load means, with this very genuine doubt for all the people. Sir, if the lagging load is given, concentrate here. If the lagging load is given, suppose lagging 30, etc. How do you know? Means lagging load. Load means phase only. That's why I phase lags with V phase by 30 only. Electrical people should remember this, because it's come to your life itself is lagging, leading only. IN people also, for you also I'm saying, if the load is lagging, load itself is phase. Load means phase. Phase means I phase to V phase only, not to line voltage and all. Just now I explained, right? Akshay and Shilpa, right? Two are same questions. Shiva Prasad, what I told you, if you send the diode question, what did I say? What did I reply in WhatsApp? Shiva Prasad, what did I reply? You send one diode question, what did I reply? Right. Always lagging load with respect to current, with respect to phase only. This genuine doubt for many of the students. Load, you are missing something. Load means phase. Phase means phase current, phase only. That's why I'm giving here again. Shiva Prasad, what did I answer? Did I say that we'll solve it in a class? I told that it will be taken the electronic measurements. Diode questions are in the electronic measurements. I will be taking at that time. My way of taking is step by step only. I don't jump from here and there. Our subject is electrical measurements, right? Okay. Right. Imtiaz Pasha, 27F. Yes. See, this is the rated current. What do you mean by that? If the primary consists of 50, secondary will be 5. But how much primary is consisting of? 40 only. That's why you've taken. If the 50 is there, 5 will be there. But 40 is there, how much will be there? That's what the point. Right. Pallavi, kindly don't mind, ma, that power system faculty will give more clarity on that. Earthing and neutral, he will give more clarity. Don't mind. Even though I give you, it may not be clear. I hope. That's why kindly power system faculty will do that. Come on. Shivanath Ganesh, after moving the switch to Y, we are taking line or phase convention. You are missing something. Star connection, line or phase, both are same. Star connection, line or phase, both are same. Next. Akash. Sir, in unbalanced system, if neutral is present, why we are not using 2 wattmeter method instead of we are using 3 wattmeter? See, neutral is there. 2 wattmeter method is not applicable. Why? Neutral wire is there means that must be the written path. Suppose neutral wire is given by the manufacturer like this. Right? If you are using, this is neutral, 1 wattmeter here. You are using 1 wattmeter here. Means this is R, Y, B, for example. You are using B as the written path. In one system, 2 written paths. Not acceptable. That's why I told you clearly. Blondism table I gave, kindly go through that. Right. Bhaskar, in delta connection, you said opening load means whatever the branch is there, that you have to open. But as the operator, we cannot open. That I told you. Right. So have you derived expression for delta? I have given the star. What is it? Star delta you want. Okay. See, in delta connection that you study in the network, that's why all I told you related to my measurement only I'm taking. In delta connection, okay, for safe side point of view, I'm giving in delta connection, VL is equal to V phase you get, IL is equal to √3 I phase you get. This is not my point. Don't worry, I'm not skipping anything. Don't think like you are not explaining this one. Kindly I'm requesting. Idea purpose I'm giving. In the circuit theory, you will get these points. If I have repeated already 2-3 times, don't ask me to repeat again, kindly. Right. Right. Vinita, that's what I told you. Sir, in 2 wattmeter method, we are measuring power in Y phase 2 times. No. So what? Finally, we got. Which one here? 3 phase only. Finally, we got 3 phase only. That's why I told you. Other people also ask the same question. Sir, in the 2 wattmeter method. Yes, in the 2 wattmeter method, people are thinking like, sir, here, right? In this B phase, we are measuring 2 times. See, don't think like, sir, this is 2 times. this is one time, this is one time, it is 4 times. No, that only I proved that that is not correct. Yes or no? Even though it is looking like 2 times, finally with proof only I told you, with proof only what you got? Finally 3 phase only. What you can understand now? Okay, it is measured twice means this is not full, this is also not full, partially. Combination we are getting the total 3 phase power. That only I give mathematically here. Right. Reactive power purpose and all you will study in your power systems here, right? How to recognize the apparent power? Come on here, apparent power formula. V into I, VL, IL, VA, volt ampere, volt ampere. That is simply, what is that here? Apparent power only. Based on the unit only. Based on the unit only. And Shivani, thank you so much. That's why I'm keep on saying that. Keep on saying every day. Until I stop speaking, until I stop speaking, you should not type anything. I told you. Those who are asking the doubts, 100% I can give the guarantee. Those who have those are the people typed, not many, few people typed while I was explaining. Many people, many people. I can actually 500 members are there, but I since still I could remember your names because every day you only typing because no, you are not listening. No, 2, 3 people or 5, 6 members. I'm able to remember your names also. Right, Bhavani. So in the problems, the watt meter reading is the power consumed by the load. Power consumed by the load. Right. In 2 watt meter method, the combination of 2 watt meters, we are going to measure 3 phase power. That you should say. Sanjay Kalaskar, don't say that statement. Simply you should say with the 2 watt meter method, combination of 2 watt meters give total power. That's it. But don't say individually combined, etc. etc. Right. Thank you. Whatever you people require, I give everything. But few people are not letting me to give that clearly. That's why I need to repeat these many times. Nita, thank you so much. All right, come on here. You people asked the textbook, no? Actually, due to some other slots, I forgot actually. Yeah. I wanted to send make the link. Actually, I forgot here due to some other lot. Okay, I'll send that Sahana textbook, no problem. But I'm saying that in the Sahana textbook, no one should follow. No one should follow all the lengthy numericals, tricky questions because those are conventional models, not GATE or ESC objective models. The two in the conventional also, even in the conventional also, so many things are not there in our syllabus. That's why be clear with the terminology. Textbook is totally not our syllabus. Textbook is totally not our syllabus. Our syllabus is only very small thing, very small thing. According to our syllabus, you need to concentrate. But don't mind it. Actually, I forgot due to some other slots. I'll send that book. No worries. Right. Very good question. So, Janya, as of now, you're solving, you're understanding, but how to proceed? That's why I told you. After going home, same question you need to practice first. If you practice the same questions in the same order once or twice, automatically, once you see a new question, what is the first method sir told that? See the wattmeter connection. Then potential coil voltage, write it. Current coil current, write it. Angle, cos of angle. Next step, what is VL magnitude? Get it. What is IL magnitude? Get it. After that, angle, given directly, happy. Not given, phasor. These are the steps to proceed. These are the steps to proceed. Very good. Thank you so much. My intention is you should get full confidence on this subject. You may be getting 3 or 4 marks, small less weightage only in the gate, but in a lifetime, definitely this subject will be very, very important, playing the major role. Okay. Shiv Prasad is giving one suggestion. Sir, all textbooks, PDF, all subjects are there in GATE Electrical Engineering channel in Telegram. Name itself is GATE Electrical Engineering. Okay, and I also try. So everyone, those who are on the link, GATE Electrical Engineering channel is there, I think. Telegram, in the textbooks are there. It seems he's saying that. You can try. Definitely. Bhavani, does the laws occurring in the machines are definitely. Laws occurring in the machines, definitely we're neglecting only. Can we move the chart also? Imtiaz Pasha, actually, I don't know. I will try. Shivprasad, kindly to my WhatsApp number, send those Telegram channels names. I will also check it. Right. How to practice this topic properly? Be clear, guys. You need to follow my steps. See the circuit first. First of all, don't get tensed. Are this much bigger circuit? No, actually, you will not get no one question bigger than this structure. I can give the guarantee almost. There is a bigger circuit. So therefore, first see the question. What is the given data? Write it. What meter connections playing the major role? Where it is connected? R to Y to B to R, like that. You need to take it step by step. If you do, definitely. First of all, leave the second thought off. Second thought of it is bigger, how, it is bigger, how, it is complicated. No, first leave that thought, you will get it. Okay, Vinita, yes, the channel have all the textbooks. Okay, kindly send the channel name to my number so that I can share to many students. Actually, I don't know that. That's why I'm asking them to send the channel name. I'll share you, no problem. I think electrical engineering ebooks, electrical engineering, GATE electrical engineering channel, it seems. Right. If the phase sequence is changed, Dinesh, don't worry. If the phase sequence is changed in our topic, power consumption will be same. But in your missions, you can understand that if you change the phase sequence, the rotation of the mission will be reversed or not, like that. So many questions we study in the mission. But in our topic, phase sequence is reversed. Positive becomes negative. Magnitude will be same in our topic. That only I have taken. While I was explaining the mission, synchronous missions and all, I'll take generally. But here not required. Right. Actually, dynamometer is a transfer instrument. Actually, all these are these type of miscellaneous questions I'll be taking at the end of the session. No need to worry. No need to worry. Is it transfer instrument or not, etc., etc.? I'll be taking at the end of this. Means so a few miscellaneous topics are there. Those will be taken. Why it is called as transfer, etc. Long back the topic was there, but nowadays only measurement is there. That's it. Right. Okay. We need this. See, channel name EE Gate Electrical Engineering Books. EE Gate Electrical Engineering Books. Even I too don't know this. EE Gate Electrical Engineering Books. Can anyone join in that? Where it's not coming, some other things it is showing. Kindly to my WhatsApp number, kindly send that link so that I can. Thank you, thank you. Few people are sending. I'll share that later. No worries. Right. Dwarakesh, thank you. Good night. Okay. Next. Actually, from faculty side, we should not have any groups. Students side, you may be having different groups. It seems. I too don't know. Right. My WhatsApp number. People are asking me WhatsApp number. This one on the screen. It is visible. Yes. Yes. What are the group is there with you? Kindly keep all these link names, channel names in that group so that everyone can benefit it. Don't worry. Once I get it, I will share you. Don't worry. Definitely, definitely. AS Electrical Engineering, AS Instrumentation, AS Electronics. Like groups are there, channels are there in the Telegram. You can join in that. AS Electrical, separate channel. AS Instrumentation, separate channel is there. You can join in that. See, yeah, I joined in that. I'm giving that name EE Gate EE Electrical Engineering Books. EE Gate EE Electrical Engineering Books. Actually, before joining only, the people will be having more enthusiasm generally. But after joining, by looking at those so many textbooks, we don't study. That's what the general human being tendency. But you can join, no problem. Okay, as of today, I'm stopping the doubt session now only because I've shouted like anything today. At least today, just leave me. Tomorrow again, just like every day, I'll spend much time up to 9:30, 9:40 and all. Tomorrow we'll be clarifying all the things. Akshaya Tota. Where I have taken point here lagging is taken. Which one? Yeah, this one. I have not taken with respect to two. I have not taken with respect to line because you're missing. Sir, the load where it is connected. The circuit itself is the single phase load connected between R and Y. That's why according to the circuit I have taken, concentrate here. Akshayama, really concentrate. What is it? Load is connected between R and Y. Generally, load will be connected between R and N, but in this special question, R and Y he has connected. Right? Actually, why I'm saying this means actually I shouted in today's topic like anything. That's why I'm throat pain is. That's why I'm requesting actually everyone. I can't speak more, so that's why I'm stopping here. If any doubt is there, kindly tomorrow I'll clarify. But follow the notes, follow the recorded video. It will be clarified, but only for today. Is it okay? Yeah. Thank you, Mridul. Thank you so much. Because every day 9:30, 9:40 is happening now. It is difficult. right? Pawan Kumar, in last year you told that, see, that is based on the assumption I told you. But now I told you actual topic. Both are equally good, but that is based on some assumption. 4 wire means true wire means fourth point is there. So why, I told you one point also. I gave two, but I gave that fourth wire is not there, but point is there. In that way, I have told you. That is assumption based, but this one is actual point. No problem. No problem. Right. Thank you. Thank you so much. Tomorrow also same time. Tomorrow we are going to conclude power measurement, and we are going to start energy measurement also. It will be completed tomorrow. Energy measurement also will be completed. Okay then. Thank you all. Good night, everyone. But if anyone is having doubt and wanted to speak with me, kindly tomorrow. Right? Only for today. Right? Thank you.